Oh, hello, hello. Let's see what we're going to do today. I don't know yet, but we're going to work on the Oncast, the programming language. There's a bunch of things that I could work on. But what should I work on? Okay, I think we need to, even although the language is still really small, I think let's make some things less special, right? I don't like special things. We have a print right now over here. The print. Where is the print defined, right? The print is defined in just as a freestanding function. While this example is supposed to be this is supposed to be somewhere in the std. Right? And we do not have the std. So I think introducing the std would be really nice. And in terms of introducing the std in general, we should have a thing where, let's say we have a 0 like that or something, right? If I try to evaluate this file, right, it will be 0, obviously, which makes sense. And I want to be able to import this file. So the import system in general, and std being the imported by default thing, right? So we once again we have this example which calls import 0, and this should be import 0 like that. I think I want explicitly to specify the relative thing here. And this is 0. So 0 is import 0. Something like that. Now, obviously, import here cannot be found. And now the question is, how exactly do I do this? Let me just remind myself how I did that before, because this can be implemented in the compiler or in the interpreter, right? Should the import happen at runtime or at compile time? Probably at compile time. But is there... could there be a use case for this at runtime? Because that's how JavaScript does it, right? Maybe there is. So we have import and import. Yeah, it was evaluated at compile time. Yeah, that kind of makes sense. But yeah, I don't know. Let's do it the same way for now. So first of all, I need to have a syntax. Syntax default over here. The syntax is going to also live in the standard library eventually. Hello, Happy Nora. Welcome. All right, first I need a syntax for importing. So I have syntax for import, which is going to be import some path. It should not have priority of 0. Why is this red? To do. Oh, I cannot compile. Okay, that makes sense. All right. Okay. What should be the priority? It should be higher than the assignment. Think. The dots should be probably after it, so maybe around here with priority like 9. Okay. So now if I go here, this is going to be a keyword now, right? And now it says that there is no core syntax import, so now we need to implement that in the compiler or syntax import core syntax. What should it do? What should it do? So first of all, the path is going to be children unwrap single unnamed, because I have named it path there, right? Okay. Unwrap single named path. Okay, then this path, so this is going to work at compile time, right? This path can be a string or whatever, right? And we're going to try it at compile time. Compiler eval C path, let path be compiler eval. So we have eval type. I want to have similar to that, just eval. So if eval type is a thing that returns expected type, an expected type expression. Why is it expected type? Just type expression and just type. So yeah, evaluate type is a thing that returns a type and a type expression. That's a star. And a normal eval would similarly return a value and a normal expression, which results in a value. So this Should just be value. This should be just expression. So value is not a type, value is a value. Its expression. Data type should be inferred as something. Should it even be inferred as anything? Yes, I think over here, infer. So like if I want to evaluate to some type, then I need to give it the type. You know, type like that. So I want this to be inferred as type. And then we evaluate not the type expression. I compile not a type expression, but a normal expression. And so I evaluate this expression. I get a value back. So now when I evaluate, I need to also give it the type. What should be the type of this? Since this is path, path should be a string. Like that. The signature for this packaged module couldn't be inferred. Don't lie to me. I forgot to say the LSP support, right? Okay, path. Path has type AST child. Okay. So this should be AST child expect AST. Okay, so now we have path as a value. And this is a value of type string. So we should basically, since, yeah, I gave it the type inferred to be a string, so we should be able to just say value expect string. Okay. So value has the things, which is expect type. And we will have also expect string. This returns a string. Expected string. The expression has type value and expression, but yeah, okay. Path. We say path and path expression. Is that right? Path expression is useful because I will want. So yeah, okay, that is actually interesting. I want to kind of save the expression because I need to have the LSP support, right? But where do I save it as? Maybe we should just have, yeah, so like over here we had the expected type expression, right? In the type description. Yeah, we have specifically type description everywhere. And in some expressions, like a function, we have the result being an expression like that. But maybe we could just store some associated expressions that we have calculated that would be just used for the editor support, maybe. Let's ignore this for now. What should this be compiled to? So I have a string, right? And now I need to be able to import this path. I need to import this path, and this is going to be so this is supposed to be a constant corresponding to that thing that I have imported. So we should somewhere have the function import. We should somewhere have the function import, which takes a string and returns a value. So imported value is something like that. Roar, hello, viewer. Hi. Hello, chatter. How are you doing? What do you think of Web3 gaming? What's Web3 gaming? It's like gaming but with scams? Is that what you're talking about? The crypto gaming? Yeah? Yeah, so basically scams. Right. Yeah, that's what I think about it. Not all of them. Hmm. Hello, Remarch. Imported value. Okay, so what I'm doing right now, I'm implementing import system. Holy shit. All right, there you go. Yeah, you know what? Like games back in the days, they were better. They didn't have casinos embedded in them and stuff like that. You know, but now there's like loot boxes and cryptos, and like they're trying to put all different kinds of bullshit in the games. You know, back in the days, the games were better. Wrong, Pokemon Red had a casino, so even back in the days they were doing this. Well, I never played a Pokemon game. Is that a good thing? That I missed the casinos back in the day. Import. Imported value. Import path. So I just so this is supposed to be a value that I have imported, and then I just say that so the import expression is just evaluates to a constant. So we just have expression constant constant value into net expression on this pen, like that. This returns expression. Wait, what should this return? Yeah, this should return expression. Oh wait, no. We should first match, right? Yeah, I should first match. What is match the kind, right? If it is expression, then we do that. Oh, with. Okay, so we also have the assignee. Can I assign to an import? Probably not, right? So this should error span can't assign to import. If it is a pattern, import can't be a pattern. And if it is a type expression, this should be like evaluated to a type. But maybe I will just have a to do here for now. Span type imports not supported yet. To do something like that. Your camera is glitching. Are you AI? Is it glitching? I mean, it is glitching sometimes. Yeah, I don't know why it's glitching though. It's a Linux. You know, like I'm using Linux, and Linux has all sorts of issues like that. Sometimes it's the microphone that glitches. Sometimes the camera glitches. But it's worth it, right? It's still worth it. Still worth it. Still would rather use Linux than Windows or whatever. Is the times when the tech hypes didn't actively destroy the internet? Imported value. Hello, Hari. Yeah, all right. So now we need to figure out how, like, where should this import even be implemented? This should be implemented where? So the compiler, since I'm doing this in the compiler. And I mean, import will require compiling this thing anyway, so this should not be in the interpreter. Interpreter doesn't know about how to compile things even, right? Because importing requires compiling the thing anyway. So compiler state is going to include the things that I have imported, right? So imported is going to be imported is what, like just a string map from a path basically, right? Let's have a separate type to it. So imported is a type where you know, like by path is a string map t into like import, you know, something something, and import is something like it's either in progress, because I am potentially right now only started importing a thing, or it is successfully imported, like done, imported. And in this case, if I have imported a file, inside of the file we always have a value, right? Okay, there you go. So imported is I think, because I have it as a separate type, this can be passed by reference everywhere, and then I can just mutate that thing because it's like a global, a single global thing probably. So I only will construct this once. I will only construct this once in the compiler. Where am I even initializing stuff? That's compiler, probably over here. Yeah, initialize. I say that imported is state initialize imported. How about that? I mean, if it is a global, I could just use a global thing, really. Nah, we don't want to use globals. Initialize imported is by path is string map empty. There you go. This returns imported. Maybe I should call this, like, I don't know. Maybe the name should be something different. Whatever. Okay, so now over here, this import should be what? Right? This import should be what? So we have the compiler. I think it's like compiler dot import using this compiler. So maybe over here we should have a function import. which is a module C as into path, which is a string, and this returns a value. Not a colon, just like that. Okay, so let's see. State of the compiler is compiler state. And then I just see. So I'm just going to match. No, I'm not going to match. I'm going to do what? State dot imported. Imported. This is the only thing that I care about. State dot imported. Right, so imported is a map from a path to the thing. So we need to first see if it was already imported or is it happening right now in progress. So I'm going to match. I'm going to match string map find opt path in imported by path, right? So if it was not, then we're going to actually import. And if it was imported, then we return this value. So we already have calculated this value. We can just import it again, right? Like that. And if it was, if it is still in progress, this means that we have recursive imports. So this should return in an error. This should result in an error saying that recursive imports not supported. I mean, they will never be supported. No recursive imports. Yeah, I feel like I need an error here. Error requires a span. We can open error. So this requires a span. So when I import, I need to know where I am right now. Kind of, right? Like this. So once again, compiler import now is a thing that requires a span, which I have here. Okay. All right. Sure. So now we need to implement the actual importing functionality. Right? How is this going to work? So we have the compiler. Compiler means that I know how to compile things. And over here we also have the evaluation. So yeah, that should be easy. I should just evaluate. I mean, that should be easy. So if this is none, then first I need to say that I am going to start importing, right? So path, so imported by path. We need to assign string map add path in progress. Right? So first we do that. Unbound constructor, because you're stupid. Of course. So we have imported by path like that. In the end, I'm going to say that I'm going to update it with the imported value. So I'm going to calculate the value here somehow, right? And then we're going to say that we have imported that, and then we return the value. Right? So now how do I calculate the value here? This should be easy. First, I need to compile this path, right? So we say expression is C compile expression AST, which means that I need to first get the AST, right? So AST is parser. So we need to have a parser. Right. Yeah, so the compiler needs to know how to parse now in order to import things. Right. It was not even in the dependencies before. So I need to add it to the dependencies because compiler depends on the parser for the import. Okay. So value is no, AST is cast parser dot parse. So I need to parse the source, and the source is going to be source read path. And path is a file path. And this should also have the rule set. So rule set is specific, some concrete syntax. So like, what is the default syntax that we use when importing files? So that should be default syntax, which means that I have another dependency, which is cast default syntax. So this should be cast default syntax rule set. So now we have the AST. Then I compile. This AST using state, which is like the new state. Blank state, but like the imported should still be there, I think. So we have scope, empty. Imported and interpreter. Oh wait, the interpreter still needs to be there. Well, I mean, in this case, the interpreter should still be the new one, right? Interpreter initialize. String map empty. Probably like that. Scope empty. When I initialize it here, this is the state that I'm initializing, right? I think this... Yeah, fine, whatever. Scope. Oh, there's init, not empty. Yeah, scope init. There you go. This should probably work. So now that I have AST and I have expression, so I have parsed, I have compiled, and then we just need to evaluate it using using state. State interpreter. Value AST has type cast parser result, but the expression was type AST. Yeah, that's right. AST is a parser result. That's right. I don't care about anything but the AST. AST over here is optional. So I'm going to match, let AST be match, no, not AST. I guess if it's empty, then I don't need to do anything. I'm going to here match AST with some AST, then we do that. And if it was none, then I will return a unit value. So this over here is value. Unbound record field AST. This is a cast parser result. So AST is an optional AST, so this over here can be now compiled. We have expression, and then we say state interpreter, or we say interpreter, evaluate this. We evaluate the expression, and this returns a value. And maybe this is all. Looks like I am compiling. So let's see that the import 0 is actually working, right? Let's see that import 0 is actually working. I restart. Is it working? So 0, in this case, I cannot hover, which means that it's probably not working. Okay, let's see. Eval example 0, this still works, but examples import 0 says that while processing import over here, processing core statement, yes. Oh, 0ks, no such file or directory. That's right. So like, yeah, that's right, because the file is relative to the current file where I'm importing the thing from, right? So when I say import, the actual path, this path is relative to the path where I am, right? So this over here, we have the span actually, right? Span contains my current file name. So path, let's see. So path is actually going to be match span file name with. If my current span file name is file current, then I will say path join, right? Or something. Is there like something that works with the paths in the OCaml standard library? Are there functions to work with paths in OCaml stdlib? No. No. You must use external libraries to avoid pain. There's file name. Wait, what? File name. That's std, right? It's the file name is an std, but yeah, the file name concat joins to paths badly. There's boss. File name extension, file name base name, dir name. Yeah, I think we need the dir name of the current one, and then I need to say file name dot concat this one and the path, right? Because path is supposed to be relative here. Right? Actually, I will first see if it is relative or not, right? Maybe I'm going to match path and then string strip prefix, which is a dot like that, you know, with some relative, then we do that. And if it's none, then I will say error. Only relative paths are supported for now. All right, yeah, that's good. So this should be concatenated with relative. You know what I think is a good feature for a programming language sometimes? Sometimes I really want to hide a variable that is in the outer scope and I need to make it unbound. You know? So like, so that I don't use the original path on accident. One way to do it would be saying something like, you know, let path be a unit, you know, so that at least it's a different type. It's going to be unused, but it's going to make sure that I'm not using it, right? Am I the only one who wants this sometimes? So I could add to cast. No? You also want that? Like I could add to cast a thing such something like, you know, I don't know, unbind or whatever, like I don't know how to call it, unbind path, right? So like the path doesn't exist in this scope anymore. Hide, like hide. Yeah, I don't know, like hide is probably like too generic. Maybe I feel like I also want some like generic names that I want to use as the keyword sometimes. To I want to have like similar to have the raw identifier syntax. Maybe we want to have the raw keyword syntax. So I would say like @hide or something, or like whatever is the keyword. So like, you know, ident. Did you switch from Rust to a camel? Yeah, I did. I did switch. Just for fun. We're having fun here right now, camel, right? Right. Imports only work from regular files. How expressive do you find a camel with relation to modeling types? It's the same as a Rust. Like I mean, okay, no, it's not the same. Like the single extra feature that they have is the generalized algebraic data types. Other than that, it's the same. There is no trait system. Although, right? So, like because of that, you need to be very explicit. Just have better iterators. You don't have iterators. You don't have iterators. Instead, you basically have a dedicated function on every type that says iterate. There is no generic mechanism for iteration. Iterator is just a function that takes the body of the loop, I guess, as the argument. It can be composed, yes. It's just like explicit. Some people might think that explicitness is actually good, though. Like, it does give you more flexibility sometimes. Like, you know, in Rust, maybe sometimes you want to have the implementation of a trait which is like local to a scope, right? That's really easy to do in OCaml because everything is explicit. Like, you basically pass the trait implementations explicitly all the time, right? Like the compiler is not trying to find the implementation for you. You always supply it explicitly. So you can substitute the implementation for something else. Could you move that information in the LSP and show an inlay hint that a variable came from another scope somehow? Could you move that information in the LSP and show an inlay hint that a variable came from another scope somehow? What does that mean even? Wait, what? They basically don't need an orphan rule. Yeah, they don't need an orphan rule because of that. Orphan rule also only makes sense, like orphan rule only makes sense because of the global thing, right? So there is basically no global state in the OCaml, but there is global state in Rust compiler. The global state being the all of the trait implementations, right? When you implement a trait for a type, it modifies the global state. And there is no such thing in OCaml. It is always local. You should, maybe you should try OCaml, but I don't know. It depends. What do you want to do? What do you want to do? If you want to, yeah, I don't know. If you're going to make another programming language, then maybe. If you want to be making games, you probably shouldn't try OCaml. If you want something with better types, you should get the Haskell, right? Go and try OCaml. OCaml is perfect for you. Yeah. Okay, concat relative. Okay, let's see. So now we could not find int32 in scope. Okay. Nice. So basically what happened is I was importing this, and inside of this, int32 is unknown. Why? Because I have removed everything. Because I have initialized a blank state, which is the interpreter which doesn't know about anything. And the scope is not, yeah, it's unknown. By the way, shouldn't this also, like, why don't I see this issue? Why is it not saying? Could not find int32 in scope. This should be while I'm compiling. Over here. Right, compiler import. So like this error is from the other file, but I don't see it in my file processing core syntax. Oh, because it's not a core syntax. Right. That makes sense. I think to have these, I need to say somewhere over here maybe. Yeah, when I compile this. So this is while processing core syntax. And this over here is a simple one. Syntax is to do. Okay. Yeah, I feel like we can remove this try catch, and we can have that try catch on the outside, like over here. Try with while processing. And then I need to like show it while processing something at this span. And what is that? And that is AST print, but print, which is a short print. Print short. AST. Yeah, how about that? I want to print short. Then I don't need to print the span, right? AST shape print short AST shape. Maybe that. While compiling this. While compiling also. Why am I compiling an expression or something? Maybe. While compiling kind compiler kind compiled kind print kind. Let's do that. So compiler, this is the compiled kind. We shell module compiled kind struct type t is the compiled kind. Print is function. If we have assignee, so this is print fmt, printf fmt, assignee expression, expression type expression pattern. So this type is a formatter, a compiled kind, unit. FMT kind h kind with. There's a problem with GADTs in OCaml where like the inference, I hate the way inference works in OCaml a lot of the times. Like, why do I need to supply this signature? I already supplied it over there. Whatever. Kind. Why is it kind? This should be called shape. So there's print, and then there should also be print short is print shape short. And print shape short is formatter shape unit format. So like I don't care about I guess token should that's fine. Rule. So like the root here, I don't care about the root though. Yeah, just say rule name. Okay, and syntax comes before mode, value after. Over here I will just fprintf fmt syntax whatever. Yeah, let's do that. Okay, so now if I do this, we will have more detailed error message, right? While compiling statement. So like this is the thing that I'm trying to compile. Then I'm trying to compile this thing, the import specifically. And then this import leads to me importing the 0. So we have this file. And then I'm trying to evaluate, I'm trying to compile this expression int32, and I don't know what an int32 is. All right, that makes sense. So in order to know what is an int32, I need to give it back the access to the built-ins. Right. So instead of having the this thing, I think I will like get rid of that, but you know, compile for is interpreter state. Yeah. You know what? I will for now just say that the blank, instead of using blank, I will say this with scope with. You know what? This is what we should have here. This is what we should have here to do. But for now, I'll say that state is equal to compiler state. I'll just use the existing compiler state, which is not exactly correct. But at least it's going to know what an int32 is, right? So now I can evaluate. There we go. And that works. Or maybe I should, yeah, I don't know, because I don't have a way to print the 0 yet. Or maybe, you know what, let's do another thing in the interpreter so that it knows how to convert an integer to a string. You know, I will import 0 like this, and then I will print, and then I will print a 0 into, like, you know, int32 to string. Something like that. So for that to work, I need the interpreter to be aware of what is the thing. We have a native function where argument is an int32 and result is a string. This is going to be the int32 to string function. And this takes an int32 value. I return a string, which is int32 to string value. Like that. Okay. There is no core syntax for the pipe. Right, I did not make the pipe yet. So we need to do this. Pipe is going to be done through macros. So let's just do that. There we go. So I'm just printing the 0. I can just run it now. Right? Okay, so I'm importing a file like that. Okay, good. Import is working. And now, since the imports are working, I want to import a specific thing, which is the standard library. So I want a bunch of things to be defined in the standard library, instead of hard coding them in the interpreter like I just did. Okay. So let's see, we are going to have the stdlib as. So in the standard library, we will have, once again, like something. So in the standard library, I will define print is going to be, yeah, and then print is supposed to be like a native function print, something like that is what we're going to have instead. And this is of type string into unit, like this. Okay. And it's missing some syntax too. Right, unexpected this. Right, because I don't have a syntax for function definition yet. For function. Yeah, and then what is a string, right? So like this needs to also know what is a string. We are going to also say that string This will need to be a constant string. Is native string. Native type string. I don't know. Yeah. Native. I don't know. Do I want this? This is just convention. I just had that before. So string is a type. So string is a type. This will say that type is unknown. So we will say that type is native type. All right. So for this to work, we need the syntax for const. Let me first do the syntax. Syntax core const pattern be equal to value. Then there is going to be syntax for a native expression. Native is similarly to the import, I'm suppose. Yeah, core native. So this is a native, just unnamed, sure. And then I'm going to say function definition. This is also not going to work. So function definition is wait, this is function type, but this has with context, right? But with context should be optional. With context should be optional here. So yeah, context is with and a space question mark. I think this will actually be parsed. Yeah, it is parsed now. Nice. So now there is no core syntax const, but we have the highlighting for it. Good. So once again, we will have print, we will have int32 to string, which is int32 into string, is a native, int32 to string. Just to like mimic what I already have, right? We have this, we also have the function RNG, which is a unit into an int32. No, it's an int32 into an int32. Right now, native RNG. I'll probably rename those though. So what's an int32? Int32 type is native int32. And this maybe is it. That's all that I need to support, right? For now. So now the syntax for const. What is const? What is const? Const is different from let, where this makes this thing to be available at compile time. Is this the direction you wanted to go to? Sure. You have a switch for the light theme too? Yeah, sure. Yeah, why not? If you want also for the future, buttons way too big. Yeah, I think buttons are way too big. It's better than it was before though. This is nice. I like it. What's this triple dot? Oh, this is from the Imgur itself. So yeah, you have the code, you have the output. There also should be in the like what I don't do on the playground right now. I'm not doing the I'm not doing a couple things. First of all, if I have an error here, this is going to to throw an exception in the terminal, but I should show the errors over here somewhere. So there should be something that tells me that there's an error. And there are two kinds of errors, right? There is the runtime error, and then there's compile time error. I guess output probably will be hidden if there is a compile time error, and we will only see the compile error. But it's also like, I don't know, somewhere, I don't know. I mean, if it's a runtime error, it's going to be just part of the output probably, right? But yeah, something about that maybe. And then there is another thing which would be really nice, is in addition to output, I want to have input, so that we can have an interaction, an interactive program run in the thing. So an input is basically something that allows me to input a line. Literally want to see warning too. Yeah, I guess warnings, right? So like even if the thing compiles successfully, maybe warnings should be printed somewhere. I don't do warnings yet, but yeah, maybe it should be like a separate tab. And so output, input is just a single line, like a REPL, to support like REPL style, right? And like an error. I don't know when though. Like if you look at Rust Playground, right. So like this actually is the entire thing is the editor. The output is not even shown here unless I try to build. If I try to build, then yeah, see that's what they have here. They have errors, standard error, standard output, and warnings, right? And then over here, they have send. This is the input over here in the bottom, right? So if I say function main std.io read main as that's mode as a string new print hello as, is this going to allow me to read line std in read line use std.io read buff read. It's probably yeah hello. Oh wait, no, what is this send for then on the Rust Playground? Isn't this supposed to be like sending the input? Anyway, we can support that. So like something similar to that input, which allows me to write interactive program, send them feedback. Yeah. I don't know, it's weird. I expected this to work. Yeah. And then this is closable too, so you can just execution close. Yeah. There's warnings and standard output. Wait, this is just std standard error, which includes the warnings. All right. Anyway, I mean, this is already like nice. If you want, I can just merge that. But if you want to improve it, like I just don't have the features for that implemented, right? For the showing the errors and stuff. Okay, we need to implement the const syntax. So const is different from a let, where it allows the thing to be available at compile time. It's like a compile time let. So this is going to be evaluated at compile time on the right side, and this is evaluatable at runtime. And technically this is the standard library. I think everything is going to be const. Okay, const. Const type doesn't, wait, no, type is a keyword, so I don't need that actually. Type is a keyword, so I don't need that, but this does need to be done. Core syntax compiler, core syntax. Const. Okay, so const. We have for const. We have pattern and value. So pattern and value is children into tuple map ast child expect ast into tuple unwrap named 2 where names are pattern and value. Okay, so we have pattern and value like that. Pattern is going to be compiled into a pattern. This always must be an expression. Right? Yes. Const must be expression. Const expression, not type expression. Not assignee. Not pattern. So we have an expression. Then I say that pattern is compile a pattern, which is pattern. Right? Then we say that value is, so value I will just evaluate it immediately, but I can get a hint of the type from the pattern, right? So value should be compile expression value. Then I will say that value data type inference type expect inferred as pattern type, right? So the type of the value must be the same as the type of the pattern that I'm matching against. The span here is value data span. Expect inferred as that. Yeah, that's like span is that. And then I'm going to evaluate that. In any case, in the end, this is going to result. Wait, what is this going to result in? If a const is different from compile time let, in that it allows the value to be used both at runtime and at compile time. So we should still generate the expression assign. Expression assign as assignee and value. So assignee is basically an assignee let pattern into init assignee pattern span probably, and then the value. So the value is going, since the value is calculated at compile time, it's a const. The value is going to be a constant. The value is expression constant value. I'm going to evaluate it in a second. Initialize expression value data n. So value here is a an expression, but we want this to be a value. Let's call this value expression. And then the value itself is the evaluated expression. So value is compiler eval the type. Wait, no, eval is like this thing. Yeah, I just say interpreter evaluate using compiler interpreter, and I'm evaluating the value expression, and this is my value. Okay, I think that's all. That's not all for the standard library though. Right? So now the const is available, but no, what is native, right? There is no core syntax native. Now we need to implement that. So we need to have another one, which is native. So native is the thing which is an expression which is going to be evaluated differently dependent on the target that I'm compiling for. Right now we only have the interpreter. But this is going to compile to a new kind of expression, which is native. So native, just children, a tuple, unwrap single unnamed, into ast child expect ast. So native expression is what we want. So this native expression must be a string. This native expression must be a string. So I'm going to say that expression is compiler evaluate, where type is supposed to be a string, and I'm trying to evaluate this. Using compiler, like that. So expression, yeah, so like expression value and expression is this. Expression value. Expression value is the value, yeah, so expression value is supposed to be a string, which is expression value expect string. Okay, and now when I do this over here, we're going to have the expression native, native expression value, something like that. So we need to have a new thing, expression native of expression native, and expression native is expression is string. If I print expression native expression, native, native expression, okay. In the interpreter, so this is where the we connected with the interpreter. If I try to evaluate the native expression, then the interpreter is going to have some natives implemented in it, right? So yeah, so we have the state of the interpreter. The state of an interpreter has natives, right? So type natives by name is a string map from this into value. We'll do this simple one for now. So I'll say that string map find expression in state natives by name. If it is some value, then I return the value. If it's none, then I will error. We don't have error here. Fail. No native expression with. Okay, when I initially do this, the natives should be equal to natives. So I call them built-ins right now. We are going to rename them to natives. Natives initialize. Natives. Natives. I don't know. Let's rename this. So we are no longer going to have built-ins at all. I'm going to rename this file to natives. It's very similar. But natives is not a list like that. So list is I mean, technically, right. Yeah, I can say that list is a string and value list, is that. But then I want to say by name is equal to list into string map of list, like that. So the natives should be equal to natives. And we will have that be specified over here. Right, yeah, type T is natives. Like that. So this is like natives dot T. Natives. Default initialize. Yeah, so this over here means that I can have some values in addition or embedding. I can support that still. Yeah, I can support that still. But the default one is basically we don't not have anything. We just have a string, have empty here. All right, and then this says when I'm applying a function, the scope is going to change, but the natives are not going to change. Can I just say state with scope being that and compiler initialization. This is initialization of the types. So if I see an expression native, then the type of this is basically the not inferred type. We don't know what the type of it is. The native is always needs to be like annotated so that we know what it is. We don't know what it is. Now the LSP hover. If I try to hover over the native expression, none. Inlay hints for native expression. Just be none. Because this is not an expression, this is a string, yeah. This is a sequence. Sequence empty. Okay. This might work. Let's see. A standard library. Restart test language server. What's going to happen? So now it says that print over here, there's no core syntax for function type. So this actually has been compiled successfully and evaluated probably too, right? So now there is no core syntax for defining the function type. That's an easy one to do. That's an easy one to do. For syntax. Function type. Function type. Wait, did I call it function underscore type? Yes. Sure. So function type has argument, has context, which is optional, and has a result. Right? Is that what I do it? Yeah, we have argument, context, and result. And then the function definition just has the body also. And but the body here is not present. Function type cannot be an assignee, a pattern, but it must be a type actually. It must actually be a type and not an expression. It must be a type expression. Okay, so we have a type expression. So we have a type expression function, which has argument, body, argument, and result. Yep, initialize type expression. Will be Gorley. Hands. State, arg, body. So we don't have body. The argument is not a pattern. An argument is a type expression. And result is also just a type expression. Okay, the context we're going to not worry about that for now. Result. Result is not optional, by the way. Result is not optional in the function def type expression, so this is just result. Like that, it's the context that is optional. Okay. Argument, result. Now I just need to say that the type shape of the so we have a new type expression, which is type expression function of type expression function, right? Where type expression function is a thing where argument is a type expression and result is a type expression. We want to print type expression function. Yeah. we can do this thing. So I will print function type. Print type expression where argument is argument. Type expression, argument, and result. And the result is equal to result. Like that. If when I want to evaluate the type, where we have type expression function, argument, and result, this is going to be evaluated as value. No, we say argument is evaluate type expression argument. And we say that result is evaluate type expression result. And then we'll just say that this must return a type. So this must be a type of a function which has argument and result. There we go. It's easy. Next, this initialization here. If I know that type expression function, I know that both of those are type expressions already, so like I don't even need to do anything. Argument and result. Can I just say underscore of type? Type of expression type is argument, just to like guarantee that the types are correct here already. So since we already know that it's a type expression, there is no additional type inference that needs to happen. Now LSP hover. If I want to hover over type expression function argument result, then it is hover type expression argument position function, or else hover type expression result. Okay. If we have inlay hints for type expression function argument result, have a none and sequence at inlay hints of expression append inlay hints for type expression argument and inlay hints for type expression result. Okay, I think that's working. Let's see again. Standard library, restart. Okay, now it says that function type cannot be a pattern. I have the wrong priority, I think, because it's trying to see that const this entire thing. Yeah, because if I try to expand my selection here, yeah, this is the argument of the function and this is the result type, right? But that's not correct. That's not correct parsing of the syntax here. So the function type should have actually higher priority than the type ascription, right? The function type should have the priority of 8.5. Maybe. Okay, everything is green, but I cannot hover, which means that this file, the standard library, has not been evaluated properly. Cast eval standard library. Okay. So string is not found. String is not found when I'm compiling typescribe here. Yeah, because okay, I forgot to do an important thing. When I have the const syntax, when I have a const, we must have the interpreter start to be aware of this thing. Const. So I have evaluated a pattern, I have a value, right, over here. I have compiled it successfully, but I also need to know, the interpreter now needs to know that this is that. So like technically this exact expression should be also evaluated immediately. Let expression is that. And then I need to also evaluate it immediately. So interpreter evaluate C state interpreter. So the compiler interpreter for compile time evaluation should evaluate the let expression immediately, right? And then we kind of ignore the result of it. Okay, then it works. And it works. Standard library, start language server. There you go. Yeah, I cannot hover on, wait, what? I cannot hover on the type description. Can I say something like, let f be, you know, like string into string, right? No, this must be a type expression, so we need to say type. Function type cannot be an expression. Type with parentheses, probably. Yeah, there we go. So now we know that this is a type. This is a type, this is a type. Okay. But I cannot hover over here for some reason. It instead is hovering the entire const expression, which is wrong. Yeah. The native can be hovered too. Okay, now that I have the standard library like this, what we need to do is we need to import the standard library. And the standard library like this, right? This is just me having certain things in scope, right? But all of these variables should become fields of the standard library, which is like a struct. So for that to work, let me just do that. stdlib begin. So for this to work, we need to declare this as something like a module. So we have a syntax again. Syntax should be module. Syntax core module. I don't know. Should probably like think about how to name this properly. Sure, module. Wrap always is module colon /n underscore. Like that. This should be any. I don't care what's there. I think because it's always at the top level. Okay. Formatter removes my empty line, but it's fine. So the syntax for module. What does a module mean? I'm no longer implementing the import syntax. So, no, making start. I don't know. It's not going to have anything there. So I want to have another for syntax, which is module. Module is a keyword here, so do that. Module must be an expression. Okay. Single unnamed, yep. Module definition or something. Okay, so what is a module? A module is basically evaluating the scope, and then all of the variables in the scope becomes the fields of the thing. That's what this should mean. So we will have expression module. You lost me there. You don't understand what this means. If you are familiar with Zig, Zig calls them structs, basically, right? Everything is a struct in Zig. It's very similar to Zig. So when you have, let me open some project with Zig. If you have in Zig, if you have in Zig something like this, const foo is struct, like that, right? Zig build Zig, Zig. How do you compile a single file? Compile. Build is using the build Zig, which I don't want here. I mean, I can just run it, saying that function main is something like that. Right? Main must be pub. Okay. So yeah, basically over here you say const foo is struct, and you say like const x is like 1 to 3, for example, right? And then you can just say that this is equal to foo.x, right? So basically every thing that you define here becomes a field of the struct automatically. So Zig is Zig's module system is basically every module is a struct. We are doing the same thing. We're doing the same thing. I just I can't make it a struct keyword 2 technically, because that's what it is. But we'll see about the namings. But the idea is something similar. Also, I guess the difference between a struct and like a module is that the struct in Zig can have an instance, like a class can have an instance, right? You can have methods on this. This over here is basically a static member of the struct, right? But you still can say that like it also is a type at the same time in Zig, right? So you can say that underscore foo is like something like that, right? It's not a let. Const foo. I expected this after a statement. Is it not a let? Const. There we go. Like, you can do that, and this should not be possible with my module system, because modules are not necessarily types. They are just namespaces, just structures with like fields. Const fn is a declaration, not a field, but it becomes a field over here. This is a field. It's a static field. There's a difference between a field like this, right? Like this is a field. That's what I'm saying, right? So the difference between my modules and this is that we don't have we only have static fields, which is like only declarations. That's the difference. So like you can think of all of the declarations as the static fields, and these fields are the fields of the instance. So the struct defines two things at the same time. And like standard library is also a struct, which means that I should be able to... So I should be able in Zig to just say that std is of type std, right? Something. Where's the std? Yeah, like this. You say that std is that, and then I say x of type std is that. Like, this technically works because std is not just a module, it's also a type. Sometimes you want that, but like, I feel like for the std this makes no sense. I love Zig. Zig is cool, but I just think that they are missing about 1,000 features. But the features that they have, they are nice indeed. It's just too simple of a language, which makes it unusable in my opinion. It's like find right C. Expression module. So expression module. Yeah, let's just call it module. Whatever. Skill issue. Really? I don't think so. I'm complaining about OCaml here too. I'm using OCaml. OCaml has the same issue of being a too simple language. Like, it just leads to too much verbosity in a lot of places. Both of these languages don't have the trait system, for example, which makes it a pain. I mean, it's not a big pain, but it is a pain. What's the bigger pain? In Zig, I think the type inference is much worse than in the languages like OCaml or Rust. Like, you need to always specify the type explicitly. It cannot be like you have a compile time function like over here, right? Std array u32. You cannot have this thing to be inferred. You say over here, tokenize any u8. Like, why do I need to specify this u8? This is unnecessary noise in the code. This can be inferred, but they don't do the inference here. It doesn't matter for like the small examples, I guess. But when you're writing like a big program, I mean, you can get used to this, sure, but that's not a skill issue. I understand how to write Zig code. I just don't want to do that. That's annoying. Similarly, the lack of any I mean, there is not a completely lack of safety features, right? But if that's a low-level language, I'm going to get a bunch of seg faults when I'm writing Zig. I already know it. They give you like the features to debug the seg faults, sure, but I'm still going to write buggy code. They are not preventing the bugs at compile time. They're only giving me extra tools to debug my bugs when I write them. But I am a bad programmer. I'm going to write bugs for sure. No hidden control flow is there for a reason. I didn't even complain about no hidden control flow. I didn't even start on that. I was complaining about other things, right? No implicit type inference is also there for a reason. Are you saying that that is also a plus? That I must to like duplicate my types in every place? Expression module definition is just expression. But when you say no hidden control flow, what do you mean by hidden control flow? Like throw in an exception, for example. That's hidden control flow, right? But that's because basically all of the languages do it wrong. OCaml does it wrong. In OCaml, the exceptions are not present in the types, which makes it hidden control flow. It's really bad, yes. I'm going to use it anyway, because there is no alternative for it. There are better ways to do it, though. It's called the effect system. Like, what is implicit? Not what is hidden control flow. When you say return from a function, I know that some people complain about the return keyword too. Like they don't have returns in OCaml, for example, right? Because return makes it, I don't know. Like some people say that you can like you look at a function at the part of the function code, you're going to assume that this code is going to execute, but no, there is a return somewhere above, which you have missed. So maybe a language with no return keyword is better. A language with no continue and no breaks from the loops is better. I've seen people say that too. Do you agree? Your language saying all languages suck? Yes, all languages suck. Yes, exactly. That's right. Then we can start comparing which language sucks less. I think Zig is not up there at the languages that suck less. because it's too low level. Unless you're writing really low-level code, only low-level code, then maybe Zig is a good choice. But I have never written such code myself. Like, even when you are writing like an operating system, you probably want to have the power of abstraction still. You don't only write unsafe code, so still Rust would be a better choice in my opinion. It's in top 7 though. I don't know. We can try making a tier list for fun. Other programming languages. I don't know if I would put Zig in the top 10. I mean, Zig is not like, once again, I like what they have in Zig. I don't like what I don't like the fact that they are trying to make Zig have only the things that they have. They are massively lacking features. That's my problem. The features that they do have, they are nice, right? It's like saying that, I don't know, like, assembly is a good language because it's easy to understand. Like, in assembly, there is no hidden control flow, right? Is that a good language now? That you would use for writing programs? Expression. Module. Definition. T. Module. Print. Expression. Definition. When I evaluate expression module, what we need to do is we need to evaluate the definition. So we need to evaluate the definition. We're going to ignore the result of that because it's supposed to be a unit. And we're going to return value. So I will just reuse the tuple for now. For that. The module. This would have been that. What are, in your opinion, the languages that are above Zig? You say top 7. So Zig is not the best language for you either, right? Even although you said you love Zig. Shape. To have a tuple where all the so tuple is basically the thing with the fields. Values, no, tuple is tuple list. Fields. No? How do I collect the fields though here? So in order to collect the fields, so I have evaluated the thing in the scope. Which means that I need to have a new scope here too. Right? So we need to have a new scope with parent being state scope. I don't have that yet. We do not have scopes. Yeah, I need to like implement the scoping properly for this to work. Mm. So I have this new state. I evaluate using this new state. The new state scope has the bindings, right? So this would be tuple is tuple of list fields, right? So fields is a new state scope bindings to string map to list into list map name value into some name and value. Okay, because tuples can have unnamed fields. This is named. Good. Pattern match is not exhaustive. Expression module. So when I initialize the module, the type of the module is let's just say new not inferred for now. But I will say here to do actually infer as like tuple, whatever. Your tier list would go number 1 C sharp, number 2 C. What? C, C++, Zig, Rust, Yo, Elixir. All right. Nice. Nice tier list. I mean, obviously I disagree with some of those choices, but it's fine. Maybe you are writing different software that I am writing or something. Okay, so the definition should be an expression that evaluates to a unit. There we go. I won't lie, Rust is a good language and the best when it comes to security, but otherwise it's just a language for devs who clearly have skill issues and compiler is there to save the day. Yeah. Yeah, I guess you can always blame the developer that they are having the skill issue. I think this is wrong though. The developer is supposed to keep the entire program in their head, and you're supposed to write C++ and keep all the lifetimes in your head instead of the compiler being there to help you. Sure, I think that's completely wrong because everyone is going to make mistakes. Even if you don't have a skill issue, you still have a skill issue. You are going to make bugs, and if there is not a compiler to help you, then you're just going to make bugs. If you refuse the help, that doesn't mean that you are not having a skill issue. Mm-hmm. Maybe we can say the other way around. Maybe C++ is for people who have a skill issue with the borrow checker. Like it's easy to go around it. If you don't understand it, then it's you are having a skill issue. If you don't understand the Rust borrow checker and you cannot work around it, then it means that your C++ is probably really buggy. Because you are not thinking about the things that you should be thinking about. Right? No? Just joined. What are we building? A programming language? Yes, I'm building a programming language. Welcome. And also we are complaining about all the languages being bad. So what's your favorite programming language? I am making this language that is called Cast. I've been rewriting it for a couple times. This is a rewrite number 3. I am just introducing the concept of modules to the language. Expression. Module. Yeah, this is in order to compile the body. This needs to have body, and then body is just a compile expression body, right? Something like that. There's so much hate for programming languages lately that I'm nervous to mention any language. People love flaming them all. You program in machine code, compilers are for programmers who do not have the skill to memorize the entire x86 64 instruction set with all extensions in their head. True. True. Ah. Oh. Ugh. Well, it's fine. It's fine. I hate all the languages. So if I say that I hate your language, it doesn't mean anything, right? Because I really hate everything. Just write your own language. That's what I'm doing. That's what I'm doing. Hello. The body. Is this body expression? This record expression just have this. There is no field body. Wait, what? Oh, it's definition, of course. Okay, LSP hover. When I'm hovering an expression module with definition, then I want to hover expression definition. Okay. When I do inlay hints for the module definition, we want to have inlay hints for the inner expression too. Okay. Let's see what's going to happen. Okay, there you go. So here's my standard library, right? Standard library is a module which defines these things, an int32, string, print, and this. So when I evaluate the standard library, I basically have a structure with these fields. So we have an int32 field, a print field, and all of those. Okay, and then it works. Nice. So the next step, now that I have the standard library as a value, like this, we should be able to print std.print instead of saying just print, right? So the hello world is no longer working. All right, it says print is unknown. So we should say use. So we should have a use expression. Or we should say std.print is the other alternative. The pipes don't work yet. So there is no syntax for dot. So like now, since I have a structure with fields, we should be able to select a field using the dot syntax. Fun examples, hello. Module. Compiler. Syntax. Okay, but for that to work, I actually need to infer the type of the STD, which which is not. Actually, it's going to say that STD is unknown, right? I need to, like right now, I would need to say that something like STD is import. Oh, wait, hold on. If it's a const, then I will be able to do that, actually. That's going to be fine, yeah. Import. stdlib. For now. Yeah, so std, yeah, I cannot hover before everything compiles, but if I do that, yeah, see, so now I can hover std, it's and we have the type of it. Okay, nice. Right. So technically I don't need to have the inference for it yet, because we infer based on the value already. Okay, just the dot syntax. For syntax dot dot dot. So dot has let me see. Dot. Sorry, here we have an object. Dot. Oh, this is specifically about the method. Dot. It should be called field probably. Instead. Okay, so we have an object and field is children. Tuple map that into tuple unwrap named 2. We have an object and we have field. Expression, compile, expression. So I have object and the field. Field is going to be it must be a simple thing probably for now. Object can be any expression, so object is compile expression object, right? And then field is match field shape with. It must be as simple. Field must be identifier. It must be a simple token. Which is simple token, where the shape of the token is identifier, like that. So identifier is identifier. We have a row and we have name. So field, we have identifier name, like that. There we go. Now that I have the field and an object, okay. This, by the way, should be like module. Let's so in theory, the should we have a dot as a pattern? Would this even mean anything? I don't know. But like the dot syntax should be usable in a type expression for sure, and in a sign expression too. But that's later. To do assign to field. To do type expression field. Okay, so we are going to compile to the expression, which is expression field, right? Expression field, where object is object and field is that. We have a new expression field. Expression field is object is expression and field is a string. Expression field, object and field. Field object is that, field is that. So object is going to be print expression object and field is string. Print maybe escaped field. Right. When I evaluate the field expression, object field, I need to first evaluate the object. Eval state object. Now the object, we're going to match object shape. If and then over here we'll say fail. This doesn't have fields. Print the print object. Okay, but if it is a tuple, then I will say tuple find. Tuple get. Yeah, field is not always actually a string. We might have like the indexing there. But yeah, sure, for now we just have get named field tuple. V tuple. Okay. Expression field object field. When I initialize this, so this is where the type inference is going to happen, and this is actually not very easy. So how do I know what is the type of the object.field? In order to know that, we need to know what the object is, right? And I have not written that yet. We need to start doing the async stuff in this. So result, so type, so I will start with type new not inferred. I will return this type. But then we need to say that once the type of the object is actually inferred, so type, let me see, inference, variable, once inferred, once object type is inferred, and you need to have function that operates on it. So we have a function object type. This is going to be type shape, right? So yeah, we just have a function here actually. Once it is inferred, by default we say error span %a type shape print other doesn't have fields. The span actually should be like probably object data span. Unbound value error. Wait, what? Probably need to open error here. Yep. So we need to basically in the type inference, we need to be able to queue some stuff to once the thing has been inferred. And then if I have the type tuple, then we'll say that the type of the field, let me say function shape let field type is match object shape. This. So if it's a tuple, then it should be string map find field in tuple, right? Or I mean, technically it should be find opt. I'm going to match here again. If it's some type, then it's type. But if it's none, then it is error. Error for. Oh, I don't have the field span here actually. By the way, I'll only store the string here. Fine, let's just do span here. No field that field is not there. I don't know, something like that. String and maybe escape field. Okay, and then I say in field type. No. Object shape has type shape. So type shape. Not in width. There we go. So it's not field type. Once inferred, we just do nothing. But the field type, we now say that the type of this thing, right? So this is the type that we need to be inferring, right? We just say that type inference type expect inferred as this. This should also give me this span. Like that. Okay. So now we need to figure out what is once inferred. So the inference variable, we should have the thing here. We should have thing here. Once inferred. So if I have the variable that is inferring this type, where was I just writing that? Over here. Initialize actually. Once inferred. Something like that. Which means that once inferred should be variable into unit, but we give it a function. So we give it a function. What do we do with the inferred value? So if we have inferred the value to be a, then we do something with it, and we have a variable, and that's my definition here. All right. Okay. We have a let once inferred. This to be function once infer one function f and variable. So we say that root data is find root variable. So root data, we store for each inference variable the data, right? And what is the data? We just store the inferred type, but I should also store what should we do once this is inferred, right? So once inferred is going to be a list of functions that know what to do with the inferred value, like that. So by originally once inferred we have an empty list. If we have new inferred, once inferred is also an empty list, right? So we have the root data. This is var data now, and root is that. Yeah, I need to like update the root data something like this. So root state is a new root where data is going to be root data with once inferred. I'm going to add this function to the beginning of the list. Something, right? With once inferred being f followed by root data once inferred, like that. Okay. So this is just me storing this. This is just me storing that. Unite data. So now if I have two things, right? Once inferred is once inferred A and once inferred B. Over here, when I unite, I say once inferred is once inferred A followed by once inferred B. But since over here when I'm uniting the data, technically the inference might have done something, right? So over here I need to pipe this to check. I don't know, let's have a function check or something. So I have this data, and then I'm going to also check here. So what does check mean? I'm going to check if it's inferred. Right? Check. Check is this. A data into a data. It's a function. Data, which is inferred, and once inferred, we're going to say match inferred with none. Then we return inferred and once inferred. But if it is some value, then it is inferred, and once inferred is going to be an empty list. But I'm going to actually apply all of the things, all of the functions that were queued here. So we are going to say that once inferred, and then we do list iterate using function f. So we're just going to call function f using the value like this. Okay. Maybe that's all. What is this? Tuple. Tuple has type tuple, but we were expecting a string map. Yeah, this should be like tuple yet named a field. This pattern should not be a constructor. The expected type is type. Get named opt. The value type has type, but the expression was expected of type shape inference variable. Yeah, so we need to have a type. Wait, what? Where? Wait, what? Where? Once inferred. No, I just don't need to do anything. But this thing should return. This is initializing, right? So I'm just initializing. What's the type? The type is just type, like that. Yeah, I forgot the semicolon there. Okay. Okay, now we just need to fix the LSPs. Expression field, object field. If I hover over a field, technically I kind of maybe want... Oh, this is like the inner one. Yeah, no, it's fine. Field is nothing. I want to hover expression object. It's fine. And then for the inlay hints, expression field, object field, none, inlay hints, expression object. Okay, let's see if it works. Let's see if anything works. Field must be identifier. Okay, because I have the I have wrong thing. I was so I was trying to actually do. Yeah, this is actually like a question for the future. So if I have, you know, like we want to be able to have method calls in the future, right? So we say like a.method, like something, and then dot method, like that. But since I have the function application without parentheses, this is like method argument, and then method argument, like that, right? But how is this different from me calling this function with this being the argument, right? Because of that, we're not going to have methods, or what? Or we are going to remove the function application without parentheses? Bonjour, do you think Twitch streamers are in need of cybersecurity professionals? I don't know, do Twitch streamers need the cybersecurity professionals? What? Because they're being hacked all the time? Are they being hacked all the time? Are they being hacked sometimes? What would the cybersecurity professional do for a streamer on Twitch? So yeah, it's even like formatting like this right now. So that's the question. What should yeah, and because of that, these things that I'm trying to call the method print of the STD here. But what we should do instead, like what we are trying, so like Rust is actually having the different syntax for it. If I want to have a field and I want to call the method on, and I want to call it as a function and not as a method, then we need to have parentheses here, which is also going to work for me, I assume. Yeah, it's actually, wait, hold on, this actually works. First try, yes. Yes, this actually works. Hello, Nerdzel. So we have the standard library, which is imported from this file. And we say stdprint is a function that I call with this. But if we have a method syntax like that, it should be different. Maybe we should have, wait, maybe I should have a different method call syntax. But what would it even mean? 700,000 crabs, huge. Oh, hold on. I am the Nerdzel. How much do you have? You say 700,000? There you go. If you want to get rid of them, you have a button now. What do you get? I don't know. What do you get? I don't know. You think you need to get something? Is just saying that you are the Nerdzel not enough to you? Okay, fine. I'll remove it. So that you don't click it on accident. Okay, how do I make this work? What should this even mean? Should this mean me trying to call the method print, but since this is a field, but this so like this should be a method? But if this thing is a thing that doesn't support methods, then it should still call like the field. What should be the thing here? I can also just remove because I don't have like methods, and I will not have the methods for a while probably. And for that, we just need to change the priority of the dot syntax. It should be higher than the function application, basically. Like 70. Then we are going to say that stdprint. So stdprint is a function from string into unit, right? This inlay hint is not the most useful one, right? If I go to the definition of the std, I go over here, because std is imported from this place. But I want to be able to go to the definition of the print. Since it's imported from there, I should be able to go to the definition here. That's not going to work immediately. Okay. And let's also make this std. Std should be like an implicit import. Two, right? Std should be there by default. Well, we should have you use stuff to. Okay, let's start by having this be implicit somehow. I mean, we don't need to be implicit technically. Like in Zig, they have import std, right? They just have std's import std, and if you don't import it, then you don't even have access to the standard library, right? We can require that, but I don't know. If this is a good thing. Maybe. std. So it's just compiler. So compiler can be initialized for the thing that knows what the std is. Okay, I think source compiler test compiler yeah, we have this initialize compile for the thing that has the std. Can I have a function like default compiler is the compiler that knows what the std is, right? So the default is just initialize for the interpreter that knows what the std is. And for that to work, I actually need to do it twice. And to actually do it twice, I need to say first that. And to first say that we have so we have the one that is bootstrapping. So the bootstrap compiler is the one that doesn't know about the std. Then we import the std using the bootstrap compiler, and then we initialize the other one like that. Explicit std is good to be clear when writing pure modules that can work on standalone compilations. What's a standalone compilation? Standard library is like it depends on what the standard library even means. What do you mean by standalone compilation? I think like in general, so like my standard library is defining, for example, what is a string, right? It's not really like the case. in a language like Zig. Why would you want to not have the standard library? Because you're targeting a system that doesn't support the standard library. So like, because in Rust you have the no std for that, right? But Rust is a little bit different. I'm not sure how Zig is doing that, but the idea is that if you like, we can have a function in the standard library like print. Print requires a certain execution context. Like it requires the like when I call the function std_print, it requires the compiler is supposed to check that we are in the context that knows how to print. You know, so if I'm compiling for an embedded system or something that doesn't do that, then I need to give it the I need to like initialize the context manually. But for the interpreter, for example, interpreter already knows how to print, so that would already be available. That's the whole idea of the language and like the effect system kind of thing. So the right now the type of the function print is just string into unit, but the full type of this is going to be string with output into unit. That's the actual syntax that we're going to use, which means that in order to print, you need to not only provide the string, but you need to also provide the output, right? And if you are not providing the output, then you cannot print. And if we annotate all of the functions like that, like for example, in order to have the RNG work, like this should be not RNG, this should probably be like get random int32, right? So this is a function that takes an int32 and it requires RNG, right? So you cannot get a random number if you don't have the random number generator. The random number generator can be provided by the operating system, or it can be provided by like you can use the like pseudo random generator, which is not actually random. Like you may be confused. There is not a lot of languages that do that. The most famous one is probably Haskell. So in Haskell you have print, and print is the like the type of print is like IO, is like string into IO unit, right? So this means that the function takes string, but it returns the action that interacts with the outside world. We are not using the monads, instead we're using the effect system, kind of, which is similar but different. The monads, they are treated as values, we don't treat these as values. That's the only difference, I guess. If you're not familiar with Haskell, I don't know that if there are good alternatives in the other programming languages. There are actually, like if you like Zig, once again, right? In Zig you have the function which is so you have a vec, right? std array list, std array list of an int32. You can initialize this, and this initialize function takes the allocator as an argument, right? So that's another alternative. You can say that that in order to generate the random number, you can say, or in order to print, you can say that this function takes not only a string but the output as another argument, because we can only print if we have the output. So this is like this is like another kind of argument. In order to generate the integer, you need to have RNG, right? Which is just another argument, kind of. You're thinking of bootloaders, WASM, and general portability. Yes. So like, you can still print on the WASM, even although WASM doesn't have the print, right? Because if you are doing this on the WASM, you are going to need to supply your own output. If you have a bootloader, you need to like like create your own RNG. But I'm still going to give you the interface that you need to implement. I'm not going to give you the concrete RNG, but I'm going to give you the interface. And if you have the interface, if you implement an RNG yourself, then you can get all of the functions from the standard library that work with the RNG. You can print to a buffer. Yeah, you can override the output to print to a buffer. Yes, you can override the RNG to be just spitting the same number over and over again, right? And that's in general, like that. So there is no global thing, basically. There is no global output. So you can only print if you have the output, you know, which is there already by default in some targets, but not in all targets. So depending on the target, the same code might compile or complain. So if we look at the example, which is the hello world, this is just not going to compile if I'm compiling for the target, which is like a bootloader, if you're trying to do that. Does that make sense? Now, if I explain this easily. But yeah, basically, it's the same idea as like the allocator, right? So allocator is not always present. You need to, like, if you're writing a bootloader, you need to implement your own allocator. So the Zig does this by not having the global allocator, but the allocator is always passed as an argument. For us, it's going to be also passed similarly to be passing as an argument, but through a different system, which is called context system. Yep. Okay, so I want to initialize the standard library here. So yeah, and because of that, I think there is no reason for me to not have the standard library be implicitly loaded, because even although it's loaded, it doesn't mean that you can use all of it. Okay, Bootstrap. We are going to initialize file 4 is interpreter. Initialize interpreter default. Interpreter is this. Compile for this interpreter. It won't compile depending on the target. That's why you think explicit std import is good. There is no difference. Explicit std is also not going to compile. What's the difference? If you import a library that doesn't work for your target, then you are going to fail to compile. Right? I mean, that's in Zig. In Cast, you can import it, but you cannot use it. Or you cannot use some parts. But I mean, technically you can use it, but like there are additional like requirements which are dependent on the target. But import is working. Yeah. So Rust does it differently. Rust splits the standard library into 3 libraries. There is the core library, the alloc library, and then the actual std. It's clear with the import. What is clear? I don't understand. What is clear? What is clear? It doesn't make the target more clear. It breaks on the import line. Why should it break on the import line? I don't think it should break on the import line. That's the entire idea. So the standard library is the library that is going to work for any target. It's just some functions of the standard library are not available on the targets. It's not going to fail at runtime. It's going to fail at compile time. If you use the API without giving it what it needs, right? You don't know on cast how to implement native functions. What do you mean by implementing native functions? You don't implement native functions. You like, it depends on what you mean by native function. In my terminology, a native function, so over here, native print. This native thing means that print is implemented on the target. I can show you the example of the previous, like I'm rewriting here from scratch, right? But previously we had this thing. The yeah, over here we have the Rust source. So here's the standard library, right? And the standard library has the print. So print is a function that takes a string, returns nothing, but it needs the output. Right? I guess no, that's not a good example because yeah. So this is not implemented actually in the interpreter here. Hold on. I guess panic. So over here, that's how you implement it. If my target is an interpreter, then I know that the panic is implemented in the interpreter already. If my target is JavaScript, then I'm going to throw an exception like this when I'm compiling to JavaScript. If I was compiling to like some native code, maybe like this could have some inline assembly or some C code. Depends on how we do the native stuff. Yeah, something like that, if that makes it more clear. How much do you enjoy OCaml? I hate it. But it's fine. I'm used to it, kind of. But I hate it, just like everything else. Bootstrap. Bootstrap. So like using the Bootstrap, I'm going to import So import requires a path. Let's have the path being a path actually. So I'm going to match path with file path, and we do that. And what are the other alternatives? Special path, and we match path with span special unknown special path this. Is there anything else? Oh, there is also stdin. I don't think I should be able to import things from the stdin. Okay, so we have a special path. If a special path is like std, then I'm going to say Path. Oh, path is a string. Mm. Yeah. Path. I think it must still be a path. So this would be a file, which is a relative. And in the other case, I will just return the other. So this is just resolving the relatives. Yeah, that's fine. But then this shouldn't be a string map. This should be like a path map. Do you have path map? No, I don't. I can just make a path map quickly. Path. Can I say module path map is map make path? Which means that path should be we should have compare. Can I have a derive compare? Derive. Deriving ac ord. Does this work? I probably need the deriver. Like that. The preprocessor on the util. Value compare is required but not provided. But that's what the ord is supposed to be doing. Ord. Ord is supposed to derive me the compare. Is this deriver not working? ppx deriving ord. Oh wait. Yes, ppx deriving ord is here, yes. Ord 2. Yes. So ord is definitely here. So ord is supposed to derive the compare. Right? Path. Oh, it says compare path and equal path. I see. Because this should be t. And then it's going to do, yeah, and it's like path is t. The other way around. There we go. It's like, because this deriver is deriving a different function, depends on the name of this type, apparently. Okay. Maybe that makes sense. Who knows? Fine. So now we have a path map. Standard libraries oftentimes come with internal state that needs to be initialized at runtime in order for some of the standard functions to work properly. And the simplest way to tell the compiler that you do not want any of that stuff added to your executable is not to import the library. Yeah, I guess that is true, because by importing the standard library, I'm evaluating the standard library code, which potentially like performs some actions indeed. You are right. But what is the actions that the C standard library is doing actually? What is the C standard library doing? C standard library is in doing some initialization. You mean like no. Is it implicit initialization? I don't think I will have that though. Like it's also like I have a different model kind of. I don't know. Like the fact that I import something doesn't mean that it's going to be added to the executable. It's different. I have the notion of compilation right now, but I'm compiling to like the internal representation, which will have the standard library, but standard library is basically a constant. It's evaluated only at compile time, not at runtime. Because that's what an import does. An import is evaluating the thing at compile time. I don't know, maybe there will be. Maybe I will change my mind later. Maybe there will be a reason to not have the standard library be implicit. I just don't really see why would I need that. So imported by path. Is my OCaml not working? Restart OCaml. Why can I not go to the definition here? I cannot go to the definition. OCaml language server is the worst. So this is not a string map. This is going to be a path map. Path map add. Path map add. Source read. Path. Read path. No idea how to open special. That's right. This means that I will be able to actually, okay. Path. Yeah, so over here, since I have the paths being special. Yeah, hold on. If this is a special. STD. Then the special STD is going to actually be a path, which is. So how do I hard code this here though? I can say std/lib here, which will work for now. So this is a file std_lib. Sometimes I want this to be embedded in the binary though. Sometimes I want it to be read at runtime. Depends. Depends. And then reading, so the source, yes, source. Should be different. So source is that. That should work for now. but it will not work on the playground though. So I import, in this case, I will import file path. Or we can have a special, wait, so hold on a second. If I say this, path, let's see, match path into string, strip, prefix, opening. We can do the C++ style suffix is that with some special, then special, none, just file path, that path, be that. Okay, string, let strip prefix suffix s is s into strip prefix option and then function and then strip suffix. There we go. Okay, maybe this will work. So now I will import from the module, make compiler is in the end there. Let's have it here. Make compiler bootstrap is going to import std. So this is this std, and I will say interpreter scope so I will say that interpreter initialize with a string map singleton. What will be your programming language compared to C++ Rust? Compared to C++ Rust is going to be better. Right? Hello. So std is equal to std basically. That's what we're going to have here. And then we're going to initialize file 4 interpreter. So this one is interpreter without std, and this is the interpreter with std. But yeah, the idea is that, so like similarly to C++ and Rust, we want to have features such as I don't know, what are the features of C++? But the most important one is zero cost abstraction, right? So we want to have zero cost abstraction for sure. And like all the other things. Like I will have, similarly to Rust, a borrow checker that's planned. That's planned. It's going to be a little different, but it is planned. There is not, I have not been planning for classes though, like in C++, so object-oriented programming not, so it's probably going to be closer to Rust. But then there is a feature from Zig, which is compile time evaluation. Well, I mean, it's not really from Zig, but people mostly know Zig. Right? So imagine Rust, but with compile time evaluation from Zig, kind of. Plus, another thing is going to have a better type system, is the idea. Then better than Rust, you know. One of the things that I don't like is that you cannot really tell if a function can panic in Rust, for example. And sometimes I really want to do that. It's not only about the panics. There is a lot of things in Rust, such as, like, if you try to use Tokyo, but you forget to initialize the Tokyo runtime, you're also going to have the runtime error. And but that should be preventable at compile time. And other things like that. Which is basically having the Rust with effect system. This expression has type span span. Okay, I will need to... where's the span coming from? Because std is a span. Yeah. Because in order to import into it, I need the span. What's the span here? Span. Span dot fake. What's fake? S. Fake std. Maybe like that. Okay, it is compiling. So now I'm not using this function, right? I'm instead using the init function. So in all of the places, interpreter, I'm not going to even do the interpreter here. The compiler CLI is just going to say that I'm going to use the default compiler. The interpreter CLI. Why is the compiler aware of the library? Like, it should be somewhere else, I feel like. Like, I should use the compiler default here, and then I will say compiler. So the interpreter using the compiler interpreter is what it's going to do, right? Interpreter is compiler interpreter, but this is not exactly correct to do. That's JavaScript. Same stuff. Compiler default. Processing. So this is for the LSP. We are going to do the same thing. Oh, but for the processing, I don't need the interpreter. We just have the compiler. Like that. So maybe just like this function shouldn't be in... Like, it should be in some other place. Could you explain harv bus to me? I need in my project harv bus. Text shaping engine. This one? Well, Havbars is a text shaping engine. Primarily supports OpenType, but also Open Apple Advanced Typography. What's your project where you need to do this? To use this? Getting STD in and out from terminal and render it like terminal? What? What do you need? This is what? This is a text shaping engine. Well, what do you mean in the terminal? In the terminal is showing the text, right? You don't need to shape your fonts there. Why is this letter highlighted? The D in the default for no reason. Now it's not highlighted. That's weird. Is that a bug in the VS Code? Like game dev, using this to render text in games. Okay. I have not used that library. I used other libraries. You should just follow the documentation of it. What's the problem? Is there a Rust crate for it? There is. There's high level interface in a safe manner. Is this one not safe? Yeah, I don't know. I used other libraries to draw text. I don't know what your question is about. You probably can ask AI and it will give you better answer that I did. Okay, so we have std print hello. So now std, I don't need to import it like that. I can just say this, right? No, I cannot. Maybe I need to restart cast language server. Yes, there we go. So now std is an implicitly available thing. I don't need to import it explicitly. And this is still working. Nice. Nice, 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 nice. This is not going to work in the browser. Let me fix it for the browser immediately. It's SuaCamel, but KS is new to me. It's my language that I'm working on. I'm making my own programming language. Cast run. So in the browser, let me just do this. I'm going to open. I'm going to open the playground here. My professor said creating a programming language can lose your sanity. Is this true? It depends on like what kind of programming language you are doing, but the one that I'm doing, I'm definitely going to lose my sanity, yes. I would say that's true. But you don't need to make a complex programming language. There is a lot of alternatives that you can do to not lose the sanity. Just make a small Lisp, for example. That can be done in a day. npm run dev. Okay, so we have the playground. Only if you're sane to begin with. Yeah, you can only lose your sanity if you had sanity. That's right. Okay, so this doesn't work. Why? Because the standard library, a static stdlib, no such file or directory. Obviously, we cannot read the standard library in the browser. This file doesn't exist. So when I'm compiling for JavaScript, I want this to be embedded. Can I even do that? Hold on. So what I want is the standard. Like, I want to actually include the entire folder. I have the preprocessor. Which is ppx blob, right? So can I have the ppx blob compiler? Down. And how can you determine which side you fall on? Creating new language. My native language is Tamil, and people started Agilang project, but it is just PPython with syntax wrapped with Tamil transliteration. It's made for school kids to learn programming. Yeah. Tamil language. You have a Wikipedia page. Huh? I think that's a different Tamil. Agile foundation language. That's wait, hold on. Is that actually it? Hold on. The Agile. Open Tamil. Provides Python package Tamil with the ability to map. So it's like just so that you can write in your native language instead of writing English words? Is that the idea? Because that's easier for children to understand? English language is not a prerequisite, right? I mean, I don't know. I started learning programming. I guess I already did know. I mean, I don't think even that I knew English. I was starting to learn programming. I don't think that was a problem. But yeah, I did learn English because I was learning programming, though. Yeah. Syntax is English, but spelled Tamil. A procedural language with dynamic types like Ruby Python. Pascal-like syntax with for and a while end. Implemented in a handwritten scanner and parser using Python. Right, well, I guess, I don't know. I don't know what's the advantage of teaching this over Python is. Or other language. But it's cool. Looks cool. Okay, so we have the this std, right? The question is, how do I import the std? Import std. This should be, if it is std, then it should be not the file, I mean the path. Yeah. And let me see. Imported by path. Boom, 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 boom. I feel like I want special. Hold on, special, and then I will do something like this. Match, special into strip prefix, which is std slash, because I will still stay std lib there. I think I want my standard library to also consist of multiple files, right? So if it is some std path, then I want file name dot concat std and std path.
Hello, Tax Zero Danchik.
Hello, Hakodanchik. So if this is, yeah, so this is not always the file. This is not always the file. This is not always the file. Or maybe it is the file. I don't know. Like I need to specify what the source is here. Most importantly. What am I working on? On my programming language. I want to embed the standard library into the binary, but only sometimes. So when do I want that? When do I want that? So can I have even conditional compilation in OCaml at all? Caml conditional compilation using the preprocessors, right? There's ifdef. Conditional compilation with JavaScript over OCaml. It's possible to do the conditional compilation based on whether the code is compiled to JS or native. I would approach this by sharing libraries but building two different executables. I do the top level stuff required for this respectively. 2 days ago I learned that you can use C, C++, Zig files in a single code base. Yeah. I mean, you can use all the languages in the same code base, technically. Just put all of the code in the same code base, right? What's the language aimed at? Everything. Everything. It's supposed to be used for everything, but I mean, I'm making this for myself mostly, right? I'm interested in making games. Here's the game that I've been making in Rust. You should wishlist it over there. So I want to be making games. So I will be making games eventually with this. Also, I like doing game jams. So if we talk about games specifically, I want to be making game jam games. So one of the important targets for me is going to be the browser. Native target also. But browser is more important to me personally. So I'm going to compile this to JavaScript and run this thing in the browser. How do I do this? I mean, I can always embed it at the same time. And from web dev, when touch desktop apps, I can choose anything. I cannot choose, like, everything is not modular, customizable, like web page. Isn't most desktop apps basically web apps these days? It's the same. Like, think about VS Code. I'm using VS Code here. This is literally a web app. Each language has a philosophy behind. True. It is. The philosophy, you're asking the philosophy of my language. Okay, the philosophy is that I want to be able to delete all of the bugs from my code as much as possible, because I am a bad programmer and I want the compiler to help me, right? So the idea is that it's a language that is easy to write, not necessarily easy to learn, and it should be reliable so that the maintenance should be easy of the code. So it's not focused on prototyping that much, even although I am going to use it for prototyping myself. I don't think that's really preventing the prototyping. So yeah, a good type system that prevents a lot of compile time errors. You know, like make an incorrect state representable, stuff like that. Is what I like. A bit similar to Nix. Nix is a dynamically typed language, so not exactly. Nix is more similar to Python, I guess. In that sense. I wish there was a better language than Nix that actually had this static typing. Or something. Nix is more similar to Lua. Yeah, I guess Lua. Yeah, Nix is a really like small language. Yeah, maybe more similar to Lua indeed. But I mean, it's Lua, but like, but it's also lazy. I guess is the big thing in Nix. Is there any other like scripted languages that actually have laziness? I don't know. There are in general not a lot of languages with laziness. There's basically the ones that I know is just like Haskell and Nix. There's probably more than that, but I don't understand what I need to write here. So I want the source to be embedded in the binary. So we use the ppx blob. We use ppx blob. Preprocessor depths a file. Can I ppx block the entire directory? Writing blob file name will replace the string with the contents of the file at a compile time. Possibly compress data without the need of respect to a COML's lexical conventions. GUIL scheme. Yeah, I never tried the GUIL. But yeah, maybe. I don't know if they're lazy. Heard people using Lua inside C for simple logic implementation. It's pretty popular to use Lua as a language for scripting. Used a lot in games, I guess. At least. Maybe in other places too. Blob file name. Issues. directory. I mean, there's only 6 issues here. Warnings about compiler libs when using ppx blob. ChatGPT. Can I embed an entire folder? No, camel. No. Your options. Use include or blob for each file. I don't want it for each file. Like, I'm pretty sure maybe I can write my own preprocessor that will do that. No folder support, you will have to list every file. You're on your own embedder. Yes. Or just use Rust. Yeah, I want like the include dir from Rust. Okay. Let's for now just do the single file standard library. So when I have a path, I'm saying source read. I know. I know. I know. What if we use the effect system here in OCaml? We have special S. This is right now just failing. It's throwing an exception. No idea how to open special S. You know what I want? I want to have a effect. Effect T SQL. Read special of string. Or what? How do you use effects in OCaml? Let's read it again. Effects OCaml. Then I can specify this at the top level. Yeah. That's going to be good. We need to say type. This type underscore effect T plus equal read special of string. Can I just do of? So like this over here is int into int t, which means that it's the effect with int. Maybe this is just, yeah, this is because this is the GADT here. So int into int. Oh, wait, right. Actually, that makes sense, right? Because this is an effect. I give the effect a string, and then it gives me back the contents of that file. So like, I mean, technically it's a string into string still. Right? Like that. So have this effect. And over here, when we have a special S, in order to read the special file, I need to say perform. Say effect perform read special S. The expression has type string, but expression was type in channel. Yes, because this is not an in channel anymore. Because it's not a channel. The way we read the special file is special. So we say instead over here input all this. So this is contents. Channel input all from the std in. Like that. Right? So now we need to effect perform read special. What's going to happen? Yeah, so this means that the standard library is like going to be a little special. And we're going to need to specify what it is. It's probably not going to be in the compiler. But compiler default Like this is a path which is special. Does not need to be done here at all. This just resolves the relative file names. This just resolves the relative file names. And if it's special, then I just treat this. So if I just try to do this right now, this is going to say fatal action. We have an unhandled effect, which is read specials std. So we need to implement the reading special things std. So that will depend now. So like the standard library is depending on like my binaries. Okay. What if I have the standard library here? Should it be like let's have folder called special files. So std is like a special file. This library depends on std and cast util. The name is cast special files. Special files. So I want to have like a function like with special files f, you know. So this is going to try to call the function f, but it will say that with effect open std stutil. If it is the effect source read special s, then expecting a comma. Yeah, we have this and we have the resume, right? That's the syntax. So resume is the resumption. Right? Let me see. We have effect. Yeah, the continuation, which you normally call it k here, the continuation. Okay, so over here, the special, right? This is where we implement the standard library. The special files, standard library is one of the special files. So I'm going to match as string strip prefix is std. If it is none, then I'm going to fail. Unknown special file s. If it is some std, then let's see. Match std path with fail not in std path. If I say lib as, this is where I'm going to embed the thing. So over here I call the continuation with that stuff, right? Is that how you do it? The expression has type effect a continuation. It's not a function, it cannot be applied. How do you say continue? Okay, there's a specific keyword. Continue the continuation k, right? This should be like effect.continue or something. Effect continue is unbound. Where is it? Effect deep continue. All right, there we go. So and this over here is like the actual contents. Contents is let's try this for now. I'm just going to open this as a file. So this should make the hello world work. Unhandled. Yeah, so like now this with special files need to be used in places. So in the cast JavaScript. So there's two ways to have the special files, actually. Right? There's two ways. Either I have the special files which are embedded, or I have the special files that are in the file system. Yeah. So the JavaScript, for example, would use the embedded. So this is cast special files embedded. And then there's going to be not embedded, but what's the opposite of embedded? I don't know, file system. From file system something. So this one will actually like read this file. Yeah, and then over here, I don't really care. I don't really care. I'm just going to say contents, which is that. Path. So path is file name concat std path, like that. So now we can choose between these two implementations of the special files. So JavaScript would depend on cast embedded, special files embedded, and the binary will, so like, yeah, the main binary that I have, this one will depend on cast special files file system. Decoupled, standalone, external, modular, detached. Oh, that's all the synonyms. Detached. I like detached more, I guess, maybe. So in my main binary, I just say, so this is the entire like main my binary, right? I'm just, since this is a binary which is native one, we are going to say cast special files detached with special files. Going to run this code main, and this over here is main. So now if I run, it says is a directory. I'm trying to open the path. What is a directory? std and std. Oh wait, it's because I have just the std, right? So now special std should be replaced with special std lib, like that. Yep. There we go. So now I have the hello. But if I try to open the playground, this will still... What will this say? No, this is the wrong playground. This is not... No, I want the local one. Localhost. This one? Yeah, so this one is still saying that we have the unhandled effect. So we need to handle that effect in the JavaScript implementation over here. So JavaScript depends on the special files embedded. So cast.js will say, I need to do this in all of the methods technically. So all of them, my public facing API. Should have that. Let's see. I just want to like have a native a thing, you know. I don't know, cross.js. Like that. Like, because this method, this is a JavaScript object, which has this as an argument. And this over here is our boundary between the JavaScript and the thing. So I kind of want like to cross the JavaScript everywhere. Cross.js function. And we'll see if the effects work in the OCaml of JavaScript too. So all my things. This probably can be done with a preprocessor too. So like every method automatically would do that. Yeah, I need to do this like over here, over here, over here, here, over here, over there, and over there, and over there. And over here, and here, and here. Like that. So all the public API goes through the cross.js function. And I say that cross.js f is going to be basically equal to, for now, it will just be with special files embedded. F. But maybe later I will add some other like special stuff. We'll see. Handle some other effects. Okay, it compiles, and then we reload. So now it says not in std libks. Right? Okay. So not in std is part of the special files embedded over here. Because, yeah, this is starting with a slash always. We need to prefix with std slash here. Maybe in the detached too, by the way. Right? Yeah. So we have std slash and then we have libks, and this is just doing that. So this is still done using OpenText. So this is still going to complain about the fact that stdlib is not such file or directory. And now we're going to replace this opening the file. We're going to replace this with the ppx blob. Ppx blob, just blob. Path to file. So this should have blob. We have ppx blob in the embedded as a dependency like that. No rule found for special files embedded rules. Wait, what? What does this issue, what does this error even mean? Maybe just could not load or file, right? That's the actual error. That's the actual error. Now it says no rule found for special files embedded rules. Oh, the rules. There we go. The rules. So this rule, can I have the file, the preprocessor dependency? Can I have this file to be like from actually dot dot slash dot dot slash dot dot slash std slash lib? Can I do that? I can. Okay, nice. Can I have over here the project root? Project. Can I refer to project root in Dune file? No? You cannot with project root. I thought there was. Like copy file. I thought I saw this somewhere. I saw that somewhere. If I look at the this thing. Copy files, project root. And they just literally told me, the ChatGPT literally just told me that I cannot do that. Let me try. Project root. Yeah, that works. Okay. So over here, I'm going to say that the contents is blob how do I refer to this here? Can I also do project root? stdlib. We don't find or load file project root stdlib. Can I say dot 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 dot? I can. Okay, I think I will try. Maybe this is a good thing to finally try to write my own preprocessor, which would preprocess the entire directory. Does this work though in the playground now? Yeah. So now this code now doesn't compile. We need to do std print, and now this works. There you go. Run. Hello world. Nice. Dimurvik. Спасибо. Okay, embed stdlib in JS. All right, that works. Hello world. How's the world doing? Doing nice. Doing nice. All right. Let's see. That works. Now I want once again to embed the full standard library. I want the standard library to be able to consist of multiple files. So what is going to happen right now? It's actually not going to work, right? Should print even be std.print? Should it be like std.io print? Maybe it should be std.io print. So let's have the file which is called like ioks, you know? Or I don't know, io slash mod ks, something like this. And then we will have print over here. Like that. And it will say std io print, which maybe makes more sense. And then we will say, so in order to have the std.io, we will say that IO is include IO. So that's a different thing now. So are you secretly behind PewDiePie, learn about Linux and stuff? And if so, didn't you show Nixos to him yet? I mean, he only started with Arch, right? Need a little bit of time before going to NixOS. So this, what? My cast language server crashed. Cast. Let's see. Yeah, so include is not in scope. Include must be a special syntax. Why did it like crash though? Oh, it crashed because like the standard library cannot be loaded because I'm working on the standard library here specifically. Yeah, that makes sense. So like if I make the standard library not work, then it's going to be crashing the standard the language server. Yeah. So maybe like the language server for cast over here, when I'm working on cast itself, should be something else. Or maybe like if I'm working on this file specifically somehow, then this should not... Yeah, I don't know. NixOS better than Arch? Depends on how much time you have. You know, like people say, we agreed that making your own programming language can make you insane. But NixOS is like, you know, NixOS is a similar thing. Maybe it's not worth it. You can just use Arch and live a happy life. Or OpenSUSE, whatever. Arch binaries are shit compared to NixOS. I don't remember having that problem though. I don't remember having that problem. It was working fine for me, but maybe like, I don't know. Maybe I just didn't measure. But I don't know. It's not a real problem, it's just a super OCD. Yeah, I think so. Okay, so include is going to be another syntax. We need to have a syntax, which is the thing. For dot. So similar to import, we need to have an include. Include is a different thing. Import makes it a separate compilation unit. Include just does it as it was a single file, as the same file. So that's different. Include path. If you wanted to try either to learn as much as possible, NixOS or Arch. How much does OpenSUSE do? I never tried OpenSUSE specifically. Like, I think Arch is good at like learning how to like tinker with your Linux in general. Nix is making you learn more, but like it can be annoying if you don't know your Linux yet. I think. Like, I think in order to go to Nix, you need to know Linux, and how to like how things work like in general. You know, like you can tinker with your Linux without, you know, something. Yeah, I think Arch then Nix makes more sense to me. Like, NixOS is two things. It's Linux and Nix, right? I mean, technically, by the way, you can try using Nix without using NixOS, right? For example, over here, I'm working on my programming language. I have Flake Nix. This just describes my development environment. So let's say that you want to try and hack onto my language, or you want to try it locally or something. You can just do this thing. You can just go and like you can clone the cast, right? So you see it says hello from cast dev shell. Over here I have the I have like Rust compiler, for example. This is the old version. But if I go outside of this directory, my Rust compiler is actually not installed on the system. I have the entire environment that is needed for working on the project to be specified inside the project, you know? So I'm installing the OCaml compiler and all of my like dependencies that I'm using, the Node.js for testing JavaScript and stuff, you know? I think this is useful, even without like the entire NixOS. The alternative to this is dev containers. As far as I know, there's like basically dev containers and this. Otherwise, or you install everything on your system globally. So like, this is nice because like you don't need to hack and install something on your system. Like it doesn't need to be present in the package manager that you're using, the packages that I depend on. If you want, you can even like do something like this. You can do nix run github castlang cast. It's going to download the repository, build it, and run it locally. And like, I don't need to install any dependencies. It's just all automatic, which is kind of nice, I guess. So this is similar to like a Docker run, but it's like based on the source code here. So I can do here. I don't have a REPL, right? Yeah, I don't have a REPL. I need to work on the REPL too in this rewrite. Oh, Nigel. By the way, Nix shell is insanely cool. Yeah. I mean the one that is with working with flakes is Nix shell, Nix packages like that. This way you can have a Nix shell. Once again, GitHub castlang cast, right? I can do this, and then we will just have cast as a binary installed temporarily. Then I exit this shell, and the cast is actually not installed. Linux, yeah, I'm using NixOS, Sir Celsius. Yeah, Nix shell with flakes is cool, right? Once again, because without the flakes, you can just only use the ones from the Nix packages. With the flakes, you can like refer to any flake anywhere. Nix for how long? I think like for a year, maybe. I'm a new guy. I'm not using it for a long time yet. Wait, can I check out how long have I installed my system? How to check when my NixOS system was installed. There should be a way. The birth time of the root file system. '23. Wait, it's 2 years. It's been 2 years. August of the 23. NVMe? No. This I have Windows installed here. This is Windows. This is NixOS over here. And we have Fedora also on this disk. All right. Real question, is Windows activated? Actually, yes. Tried Arch? Yeah, I was using Arch before NixOS. I think NixOS makes me not want to go back to Arch. But I was using Arch for like, I don't know. I don't know how long. Maybe, I don't think it has been 10 years. Maybe. At least 5 years of Arch I've used it probably. And this is Hyperland, yes. NixOS is just too stable. That is kind of boring. Yeah, like the cool thing about NixOS, you can break your system and then you can reboot into the old like version like easy. So like you literally cannot break your system. It's impossible. Unless like I mean hardware failures can happen. Okay, we want... There's no core syntax for include. We want to implement the includes. Include. So compiler core syntax, we have imports, and I will also have an include. Import. And include. Include is... Wait, include is a keyword in OCaml? What does it do? Can I actually... Wait, hold on. Can I actually include the files? Oh, no. Oh, no. Include is a different thing. Yeah, no. I'm using it. Yeah. I know what it means. So what is an include? Include. Path is path. Expression. So include should work for all of the expressions actually. All I need is to read the file over this path. So yeah, I want that path expect string. And if it's special, then it is special. Kind of, yeah. So we have that. We don't do import. But I want... Path is path expect string. Can I say path is... So I have the current span file name. I know the current file that I'm parsing. And I want to say path concat with like path like this. Probably. So, or yeah, and then we want to have AST is going to be parser. Parse the source, which I read here. So we are going to parse this using this, which is still hard-coded, but okay. We have AST. And since I'm including it, it should be not empty. This has type cast parser parsed. Parse parser result, maybe? Yeah. So now I'm going to say let AST be match AST with will it be AST or option unwrap or else function or span included file is empty. And now that I have the AST, we can say compile expression. I mean, I just don't even do that. I just say compile the kind of the AST like that. Unbound record. Span is span. You can do the same with snapshots. Yeah. But snapshots is meh. What I absolutely hate about Nix, sometimes certain binaries absolutely hate working with Nix store and cannot handle not being in FHS. True. And now that you remind me of this, my VS Code is actually the VS Code FHS. I never looked into how to use the VS Code. I mean, I don't know. It just works here. But I know that there is the version that is, yeah. I guess to use like Nix stuff inside. But I'm supposed to use the other version of the VS Code, right? I don't know. It doesn't matter too much, I guess. But yeah, sometimes you just have the thing, and then you just. I mean, I'm just using Steam Run, for example. Then if something is not made for NixOS, you just do. I just do it in this Steam Run. Okay, path concat. Hi Ogma. Hi. Hi. How are you doing? Read. Yeah. So path concat. Path can cat. So concat path with like some relative path is going to be match path with concat path relative is going to be match path with, if it is a file path, then it's going to be file name concat path relative. If it is a special path, then it's going to be special then it's going to be special this slash that, which is path and relative. And if it is an std in, then I'm just going to fail trying to get path relative to std in. I think like getting some Arch-based system with Nix package manager is BIS. What's BIS? Because you get everything with Nix and you lack something. You fill the gap with packages from the Arch user repository. Best in slot? Is there a package that is not in Nix but is in Arch user repository? Last time I checked, Nix packages had more packages than the Arch user repository. Nix actually has less packages than the Arch user repository. This over here in Russian. Can you speak Russian? Da. Yes. Of course. I'm Russian. I can speak Russian. You can use Nix on any system. Yeah, you can use Nix on macOS too, which is kind of nice. I'm wondering if Nix... No, there's no way Nix can work on like... on a Windows, right? Nix Windows. Nix on Windows. Is it like even possible? Somehow? It just hasn't been done. not the Z, not the Z. Ooh, ooh. System error, stdlib.io mod not a directory. Oh, right. Right, because when I say include, I need to first get the file name. So like we have the file name, and I need to get the directory name of it, right? So I need not to concat. Well, I mean I can concat. I don't know, relative path relative. Let's just rename this not to concat, but like relative relative to, you know, like relative to this file. So this is a file, not a directory, right? So if this is a file, then I want to concat to file name dot directory name of the file, and then relative from there. And if it's special, this is a string. I mean, I can kind of do the same thing here. Right. Can I have string find index? How to find a thing? Our index opt match path. Our index opt. No, the argument order doesn't allow for that. Path and slash none. Some index directory is string sub path index. Where's the syntax error? I don't see it. Why am I blind? 57. And the match. Sub 0 index. Okay. I mean, I don't know. Probably like the file name your name is implemented that way too, right? I don't know. Just want to rely on it too much. Yeah, and also since this is a relative, I want to first file name is relative is relative into string strip prefix, which is a dot slash option unwrap or else in relative relative path must start with dot slash std.io mod io. Yeah, so that's our std library over here. This is underscore mod. Okay, now this works. Initializing this while compiling core dot field print is not there. That's right. So field print is not there at std hello, right? We need to instead say std dot io dot print. There we go. That's nice. And then can this work on the web? It is not going to work on the web. If I reload this, It's going to say that not in std io/mod. And for this to work, I mean, for now, special files embedded, I can just embed this file. You know, if I'm trying to load the io/mod, then we're going to say std io/mod, like that, and this should be also written as dependency here, which is annoying. io mod preprocessor deps. Can I have like a directory here? Can I have a directory? Preprocessor deps dune preprocessor deps preprocessing specification deps preprocessor deps field. If your dependencies needs actual dependencies, you should use preprocessor dependencies field. It uses the dependency specification to declare to what the dependency means. Dependencies in Dune can be specified using one of the following: any dependencies file, alias, glob files. Depends on all the files mentioned by the glob. See the glob for details. Glob's file rec is a recursive version of this. See the glob for details. Source tree depends on all source files in the subtree with root dir. So can I say over here the source tree project root /std? Can I do that? Looks like that works. So that should make that work too. So I can do stdio.print, right? There we go. Now I can, so basically we can also hover. So io is a thing which has the print. std is a thing which has all of those things. This in Layhinge probably could be better, but yeah, that works. Okay. Include. And then I want to not hard code this either. I want to not hard code this. I want to have a blob directory. I want to have a blob directory. How do I do that? Can I fork the blob? ppx blob source this. Okay, let's try copy pasting this. The unlicensed public domain, nice. Is unlicensed popular in the OCaml world for some reason? ppx blob dir. Not blob, I don't know, include dir. Right, something like that. Dune. So this is library ppx include dir. ppx rewriter, ppx lib. Like, it should be easy to do that, right? So what do we have? In order to have the ppx, we need to have an extension, ppx lib extension t. Rule, extension, register transformation, ppx, include dir. Like, this should be similar to the Rust procedural macro, right? ppx lib driver register transformation. Rules is rule. I guess like this is the thing. This is the only thing that is actually needed. We need to register this rule, and this is the rule. Okay, and this is the thing. So we declare blob. Let's say include dir instead. So we declare include dir, which is a context expression, AST pattern, single expression payload is string. So we are expecting a string, probably is what it means. Where is this defined? In the AST pattern, yeah. Okay. So we expect a string to be the argument to the include dir, right? And then we expand this. Location. Expansion context, extension point, location. This is where we are expanding it, right? So like the source code location. AST builder default is string get blob. So it is expanded into a string, but it should not. Okay, so I need to figure out how to build the AST. What do we want? What do we even want? What do we even want? I want to have like a what? Like what should even be the type? I feel like this needs the embedded directory for like project on its own. You know, like included directory. Like I need to depend on that then, probably. So this is not a rewriter. This just depends on std or whatever. Included dir. Like I need to define the types here, right? Because I don't want to declare those types. So type included directory is what? So we have entries, which is a string map, right? Which is a string map to entry, where entry is a file of a string file. Yeah, and we say like file is contents string, right? Or we have a file, or we have a directory of another included directory, right? So like recursive like this. That's the entire thing that I need. And then we will be, and then I need to like generate the thing. So get blob, location path. Path is a string. Find map, read file. Open in bin. Get blob. So yeah, get blob can be the same thing. Am I implementing use? I'm implementing no, I have implemented imports and includes, but no use yet. Yeah, use also needs to be done. It probably will happen later. I probably don't have time for it today. Right now I'm doing the alternative of the include directory macro in Rust. So there is the preprocessor, which is including a blob, which is including a single file, but I want to include the entire directory. The entire standard library, I want it to be embedded in the binary when I'm doing the JavaScript version, at least. Maybe sometimes I want it to be included too. Feel like it's useful sometimes, maybe. Yeah, by the way, the Nix one is not going to work. Never mind. Hold on a second. Get blob. Like, even if I'm not including it, it probably should be configured through the environment variable. Get blob. So expand, and we need to AST builder default is string. Okay. Record. P pat record, p sig record, p exp record. That makes sense. So what I want, since this should be, yeah, so this should be AST builder default record expression, right? Record expression has the location block, and then it has the location and expression list. So what are the fields? And then expression option 2. EPX records construct the EPX record. Expression option, this is probably like the one that I'm extending. So this is for extending an existing record, probably, right? It's either with or with, yeah, with is when this is sum. Yeah, I don't want that. I want none. So, yeah. Forecast for a camel. Yeah, for a camel. I will. I cannot really write cast yet. We don't really have the language in this rewrite yet. Only some simple stuff for now. So I need to get entries in the path. That's what we need. Get entries. So get entries is, so what is read file? Open in bin, unprotect, right? Open in bin is same as open in, but the file is opened in binary mode. All right, fine. So I want to like read the entries. Is there such a thing? Open directory. Like how do I list directory? Probably. Or camel list dir. It's a thing. Module. How to list list recursively regular files in a directory. Sys ls dir. So we do sys dot ls dot this directory. Ls dir. Unbound value. Rewrites as first class. How to read directory in camel. Sys and Unix modules. Unix more controls equals file types, only file names, not no metadata. Says read dir. Read dir. Wait, what happens if the preprocessor panics? So they are protecting. Oh, they're just closing the file. That's why. Yeah, they're just panicking. They're throwing in the exception if the file doesn't exist anyway, right? Read file. Oh wait, no, they are catching all exceptions, and all exceptions return none. Okay. Yeah, we can do that too. Location error. Yeah, that's what I need, right? So we are going to try with underscore and then include dir could not find or load directory path. So we try to read directory. This is a string array. It returns the names of all the files, but we don't know the file type. And Unix read dir. What is Unix read dir? For Unix, this needs to depend on Unix. Unix read directory returns the next entry in a directory. What? This. So we have a directory handle, we open directory path. Then we loop with this. Unix read dir opt unbound value read dir. Read dir is going to give me a string. Return the next entry in the directory. Erase end of file when the end of the directory has been reached. Try. Let. Wait, but how do I know if it is the file or not? What? The entry is only giving me the path. Where's the next entry, which is a string? Why is it just a string? I need to like have file kind or something, right? Do I even need the Unix? Maybe I can't have the sys. File exists is a regular file, right? Sys directory, like is directory. Yeah, we can do that. Okay, fine. Fine. We're not going to depend on the Unix then. That's better, right? So we are just going to say sys read directory path. Right, so this is the entries, and then I'm going to say entries map entry into. So what does this even expect? Long indent and expression, right? So I need to convert this into an identifier of the field in the thing. So identifier is probably AST builder default. Probably. Can I have the autocompletion, please? Oh, Camel. Please. Oh, Camel. I want you to give me the autocompletion. Come on. Unbound module, AST builder. What do you mean unbound? Over here it's bound and over here it's not bound? What do you mean? Did I have a typo? No, I don't have a typo. What? What do you mean unbound? Unbound module AST builder. How is it bound over here and unbound over here? That makes no sense to me. Open ppxlib. It's opened. I mean, this is one of my dependencies, right? This is what the ppxlib depends on, I guess. Like, it's working over here, but not over here. This makes no sense, right? The value entries has type string array, but expression was dependent on type a list. Oh, it's an array. Expression has type a array. No, I want to list. Array to list. Expand. The value has type this, but expression was expected of this. String expression, and this is expression option. Expand. Yeah, because this should have a none, right? We don't expand it. Yeah, so like this compiles. But this compiles, I still have the AST builder, Nigel. Why do I need to open anything? AST builder. It's not here, but it is. Oh, wait. Oh, let's open ppxlib. I see. Wait, why do I need to do that though? Why don't we just open the ppxlib at the top? Why don't we just do this? Why not? Yeah, so identifier is AST builder. I need to build identifier. Expression identifier. No. I need the long ident lock. Lock. How do I make a long ident lock? What is lock here? This is just location. Long ident. How to construct a long ident lock when writing ppx. It's just location and this. So this should be a long ident lock, right? So long ident, no, this is L ident, L dot, or L apply. Okay, I mean, we just want the identifier. Right, I just want the identifier. And lock is text and location. So I just say text is lident entry, and entry is a label. Wait, what? Oh, this is labels. And lock is lock. But label is a string, right? In this sys. So this compiles. So we have identifier, and then we so then I want this should return long ident long and expression. So ident and expression. And what is the expression? Entry expression. Expression is expression, right? This is going to be match sys is directory entry. Wait, entry is just a label, right? I need to have like the full path. So this should be like probably file name concat, right? Let entry path is file name concat path entry. Probably, I'm assuming that this is not including the original directory path here. So if it is directory path, then if it is a directory, then we get entries. Lock entry path. And if it's false, then we get blob. Location entry path. Right? But this is not correct. We need to still, so like get entries. This is that, so this should be still like a record, like that. Yeah. So we need to say AST builder and to construct a variant. PP expression variant. Location. Label is going to be the directory, right? So this is a directory where the inner expression is also going to be the AST builder default record. Like that. It should be recursive. And this is optional. So this should be some. Like that. And then if it is not, then the variant is going to be AST builder default variant. So the variant is file, and the data is some this thing, but this is a blob, so this should be creating, yeah, blob is giving me the string, which is the contents of the file. So we need to construct AST builder. We need to construct this string, string. What is string? Constant, log, and t. String like that. Log. There we go. I think this is the entire thing. So we read the file, we read the directory, and then if it's if an entry is a directory, then we read the directory recursively. Otherwise, I read a file and embed it as like the file. Is there a thing in the OCaml like cargo expand, which expands what I have generated? I have generated some OCaml code here, right? This was easy. But also, I wouldn't say that it looks better than the Rust way. I think it's actually worse, because like in Rust I would use the quote crate, which makes it look nicer, I think. Anyway. So then we do the special files embedded should depend on the ppx include dir. Right, so blob is now no longer there. I will instead say that std. Oh, so and then include, and then this should be on included dir have dependency, right? So std is included directory, included directory, and this is equal to include directory std, right? Okay. The record expressions have to expect to have type included here. There is no field detached. Wait, what? Oh, libks is equal to that. Yeah, yes, yeah, okay, that makes sense. They just show me the ppx expanded over here. That's nice in the error message. So that's the file that's what I have generated. libks is equal to that, and this is equal to that. So yeah, yeah, that's right. We need to do it differently. This is the entry that I am doing, but this should be done with a let, because this is actual code. This is more like string map of a list or something. Is what I need to do. Yeah, because the field is not like, we're not making JSON, right? Libks IO is this. IO is a directory where modks is that. Yeah. But that's not how you do it. Right? We need to say that we need to say include directory location path. And this should be over here some include directory location entry path, where include directory location path is equal to. So first we will get entries. Let entries be get entries location path. But if there are seam links pointing to outside of the directory, yeah, well, we're not going to do that. I'm not going to handle that. Include directory. This should return an expression. So we have an expression, which is a let, right? AST pattern. AST builder. Default. Let. Expression let this. Location. Recursive is false. Value binding list. I'm going to have a single binding. I'm going to have a single binding. And then we have expression. Expression that follows, right? Expression that follows is going to be AST builder. I'm going to build the record. I'm going to build the record. And then the list over here is going to be the identifier. Identifier is identifier. So we need to include a directory. Yeah, we need to have the entries. And entries are having the expression. I'm not going to have a let, actually. We're just going to inline it there. Yeah, we're just going to have a record where these entries are. I'm going to call string map of list, right? Entries. Where entries is AST builder. Call. Apply. We need to apply. Apply has arguments, expression, and then the list of label and list of the arguments. Okay. So the expression is going to be string map dot of list. How do I make string map dot of list? String map of list. String map of a list is AST builder default. Maybe it's this. Maybe it's a long ident because it's L dot. The long identifier is used in parse trees. It's not an expression to have a dot, right? It's an identifier. What is apply? What is a dot? Long ident and string. Yeah. Yeah, I think string map of list is just long ident. So this is, yeah, this is going to be AST builder default ident. So the identifier is going to be L dot L identifier string map. So string map dot of list, right? That's what I want. I want string map of list. Like that. So string map of list, and then I need to construct a list. So these entries should actually be a list. So yeah, all of those, right? Let entries be that, and then I will return a list. So AST builder list. How do I make a list? How to create a list with AST builder. EList. Okay. EList. EList of the expression lists. EList. Just expression list into expression, right? So just entries. So every entry must be a thing. So this should not be an identifier, actually. This should be just entry, which is like the name of the entry, right? Yeah. Entry expression. Entry is a label, right? So I need to AST builder make a tuple, right? Which is maybe e product, e comma, e tuple. What do they call it? How to make a tuple, maybe. Pexp tuple. Why does this is a pexp tuple? Lock. So we have a tuple and then we have the expression list. So the expression list. The expression list is these two things. The entry. So the entry is going to be a string. So AST builder default is string entry. And then we have the second, which is the actual value, which is the entry expression. It's already an expression. There we go. So entries is now an EList. Entries is apply. So I need to apply string map of list to the list, and the list is the entries. Entries. No, pxApply applies to the list of arguments. So we have the only argument, which is entries, and it has the arg label. Arg label is no label. So I need to say no label entries. No label entries. Apply. List entries. Entries. E-list, I forgot the lock here. There we go. Okay, it's going to work. First try. Let's see. It says could not find or load directory .std. Can I just see what it is? No such file or directory std. Wait, what? But it was working. It was working there, so I cannot read it. Std include directory. Unbound record fields entries. Wait, what? It's included there. Oh my god. Unbound record entries. Why? Why? It's because over here I need to have annotation. I need to have annotation. Can I see what it generated? I cannot see what it generated. I think I just needed this to be annotated. That expression is this. Can I have AST builder ascribe type how to construct type ascription expression type. You want to build a type ascription? Oh, it's a colon, not a double colon. It's called p expression with type is PEPS constraint. PEPS constraint. Constrained expression with a core type. The type constrained expression with core type. What's a core type? Type core type is AST builder default type monster just long ident, right? Oh my god, looking at this source code. Oof. Migration stop talking. Lol. Why do they have migration stop talking in the entire source code? Stop talking, stop talking, stop talking. Funny. So I construct text p-type ident p mod ident, expression ident, m type ident. That is module type. p-type conster. Sure. So it's a constructor with no arguments, I guess. So over here, I'm expecting to see text, which is lident included directory, and look. Where's the syntax error? Once again, I don't see it. There is no syntax error, don't lie to me. That's what I need to return, like this. Unbound type constructor included directory. There we go. We can actually do l dot included directory, but also lident, because we need to like do the module included directory, like that. Expression has type string map. File of string map, but an expression was expected of type included dir entry. Okay, variant. This is polymorphic variant. This is polymorphic variant. I want something different. Constructor. Exp construct. Constructs a PXP construct. What is a PXP construct? Represents C, CE. When exp is none. Yeah, so this is the thing, which is a directory. Okay, fine. What is this again? Long ident. txt is ident directory. And this is file. And this is not a variant, but a construct. Okay. Unbound constructor file. And now I need to annotate the file over here. This file needs to be annotated. Wait, I can just say over here. Instead of that, I can say l dot lident file and no lident included directory dot file. Like I can do that. This constant can type string, but expected as type included directory file. Right, because the file needs to not have the string. This needs to have the contents. Right. I'm almost there. I'm almost there. I'm going to say file. Yeah, so like contents is this, and then file is ast builder. We need to build the record. We need to build a record where field is contents, and the value is contents. Okay. Uninterpreted. Okay, hold on. I think it works. I think it works. I think this works. I think this works. It compiles, which means that it works. All right. Okay, so std is an included directory, and now I just need to find. Now I just need to find the file in this included directory. So find in std path. There you go. Right? Yeah. So let find in is basically included directory into string into string, right? Which is a function directory path into. I'm going to match path string find string index opt path of the first slash. So if there are slashes, then we want to find a directory, right? So some index, we do one thing. If it's none, then I want to find a file. So if we want to find a file, then we're going to match directory dot entries string map find path. I'm not going to match. This is just what we're going to return. Oh no, we need to match because we must like confirm that it's a file, right? So if it's a file with contents, then I'm going to return the contents. But if it's not, then we're going to fail. This is not a file. Let's do then find opt actually. If it is, so if it is some file, then we do that. If we say that it is some underscore, then this is not a file. And if it's none, then we're going to say this doesn't exist. Path, like that. And if it is a sum, so in this case, I say that dir name is string sub path 0 index, and then like rest is string sub path index plus 1, and path and string length path minus index plus 1. I guess that's how you write OCaml. Sure. And then I want to say I'm going to match once again directory entries like that. So now I expect to have a directory, right? A directory. So then I'm going to find in directory the rest. This is not a directory. Your name, and this should be recursive. I think that's it. Expression was expected of type string. Where? Cross.js. This is no, Cross.js should be a function. Unit into A for all A's, right? Can I do that? Because cast with special files. Okay, maybe this is not working. This should be A unit into A. So F type A F unit into A find in. Oh, this should be like, yeah, this should be like actual contents. Contents is this, and then I need to continue the continuation using the contents. There we go. This is like effect deep continue. Okay, it compiles. It compiles, and it means that in the cast playground, we can do std.io.print. Can I? I can. Okay, there we go. So we can have includes like that with embedded standard library, and like we're using effects, and it all works in JavaScript, and everything works. Okay. This wasn't difficult, but it is, I will say, more difficult than... I mean, it's not difficult. In Rust, figuring it out is more difficult, but in Rust, using it is easier, I think. The procedural macros, I mean. But it's pretty short, just 100 lines of code to include the directory. Right? Okay. Include dir std for embedding std. Okay, that's going to be it for me for today. That was good progress. I need to go now. Thank you for watching. Do you prefer features or bugs?
8675309. No.
I don't know what this is about,
I'm busy.
but I like the title. Guys, next time, thank you for watching again. Bye.
Which voters have vanilla votes? Pick up your phone. I can't believe you just doxed my phone number. I know, right? You're gonna get all the phone calls now.